Okay, welcome everybody. Welcome to the Keshe Plasma Reactor Group. I'm Rick Crammond. It's Tuesday, August 16th, 2016, and we're here gathered once again as following in the tradition Keshe, which we've come to know and like over the last weeks, months, years, days, hours, depending on who you are on the planet. But we've been meeting here, many of us have been meeting here for up to 3.5 years or more. And now we're sort of at a bit of a peak, you might say, in our endeavors to create reactors and create plasmatic devices. And right now in Washington, D.C., there's a group of people who are presenting the Keshe plasma generator, the Magrav generator. And so as experimenters, we are encouraged to also try to replicate this generator in order to get this knowledge out to as many people as possible, and to also replicate the idea of going to the governments of all the countries of the world, similar to what Douglas has initiated in the United States. He traveled for 2 days in a vehicle with his Magrav's plasma generator to Washington, D.C. to basically show the government, show President Obama, and to just get the concept, the idea that life is about to change quite significantly in the way we handle energy and the way we can do many more things with what we have, basically. And in that light, the doing things with what we have will be sort of the focus of this little workshop today, I think, because it's always been sort of the theme with the Keshe Plasma Reactor Group, for starting right back from rotating ping pong balls to different ways we pull things from the thrift store and the local hardware stores to for our lab equipment, so-called lab equipment. And it's kind of outrageous in a way, but yet this is the grassroots way that this technology has been building and has been developing. And I think that's encouraged somewhat, quite a bit actually, by Mr. Keshe and the Keshe Foundation. At the same time, we're pushing in other directions in a perhaps a little more controlled and scientific manner, with various organizations and universities and governments and so on are getting more and more involved and more interested in alternative ways of generating this elusive energy or power that we supposedly need so much. And so I see here there's a countdown, 16 hours, 43 minutes, and 29 seconds until the presentation of the off-grid Keshe generator in the, I think it was the Sarah McLaughlin. Sarah, it doesn't say on the whole message here, unfortunately. I don't have it. Somebody help me with that. I have to find my. Is it Sarah McLaughlin conference room? I have to find the full message here.
Just Rick, can you hear me?
Sorry, I'm not. I just realized I didn't have my headphones plugged in here, so things are probably not sounding very good. Can find the headphones. No, I can find the headphones. I'm not finding the cord. There we go. Just a minute. Sorry, folks, on live stream. It probably wasn't sounding too good because of the echo factor. Hopefully it's better now, and now I should be able to
Can you hear me now, Rick?
perhaps hear people better. I'm not...
You're not hearing anybody yet?
You can hear me, Joan?
I'm not
Yeah,
hearing somehow what's going on here.
Say that again, please.
Yes, you're coming through. Your little
The sound's
but
not coming
Okay,
through
just making sure.
on my computer.
Testing,
Probably
testing.
seeing the levels go up and
You're
down.
talking, I'm
Nothing,
not
no
hearing,
talking.
so I've got some issue happening here with my sound.
Yeah, I
Hear
hear
us
Just
yet,
a
Rick?
minute.
I can hear everyone talking.
Yeah, everybody can hear except.
Okay, I know what's going on. Just a minute. Okay, I think I have it now.
Can you hear us now, Rick?
Yes, I can now. Sorry about that.
Okay, no problem. I was just saying the latest information is on the Keshe Foundation website. We
Okay.
just put an announcement out, probably not even 20 minutes ago or an hour.
Okay, let me get that up here. I'm sorry, my sound wasn't working. I didn't know it. I thought, gee, everybody's being nice and polite and quiet.
What?
But that
No,
was...
quite the opposite. We're yelling for you.
Yes, I'm sure that it'll come up on the live stream and I can replay it later. I couldn't hear it myself. I saw the live stream thing flickering, but I couldn't actually hear it. Okay, let me see if I can get this up here. Okay, this is the main share screen. I'm going to be looking at the main Keshe Foundation website page at www.keshefoundation.org. And if you scroll down a little bit, you see in big letters, real nice, for immediate release, and so on. And this is about the Keshe Foundation presentation and demonstration of free or cheap energy devices on Wednesday, August 17th, 2016. And it says come at 6 o'clock p.m. for dinner with the speaker, or at 7 p.m. for the presentation and demo, and or 6:30 p.m. Zoom public ID 939-474-503. That's the usual Zoom ID we use for the Knowledge Seekers workshops. Or live stream and YouTube live broadcasts. There'll be ways you can connect with those links as well. It's going to be at the National Press Club, the McLennan Room. Maybe it's Sarah McLennan Room, I guess is the name there. McLennan Room, 529 14th Street Northwest, 13th floor, Washington, D.C., 20045. Free parking after 5 p.m. There'll be Armin from the Keshe Foundation will be there, and other Keshe representatives. What's going to happen? It says attendees will see and hear a Keshe Foundation presentation and demonstration of a Tesla-type fuelless standalone generator that generates electricity for an average-sized home with no connection to an electrical outlet, no batteries, no oil, no gas, no coal, no nuclear, no solar, and no hydroelectric. Keshe Foundation intends to replace oil, gas, coal, solar, hydro, and nuclear for the generation of electricity, for powering moving vehicles, and for flight. Other applications are also forthcoming, including healthcare, desalinization, and agriculture, as per the Keshe Foundation. So this is pretty exciting, actually, and many congratulations to the Keshe Foundation and the people involved that went actually to Washington and arranged for this to happen and so on. It's a major accomplishment to even get as far as it has at this point. So in that respect, what's happening now is Mr. Keshe and the Keshe Foundation are requesting that people that are experimenters attempt to replicate the the blueprint, the hybrid plasma generator blueprint, and I think that would be an interesting thing for people to get into. So if we go and have a look at the actual blueprint here, let me just pull it up. And actually, just I'll share it here. I'll show you how you can get to that easily. I'll just share my desktop's probably best. Okay, so this is the basic blueprint, but I wanted to show the page you can use to get there. There's various ways of connecting to the blueprint.keshefoundation.org page through the Magrav's Power Blueprint, or the blueprint constructions for people's creations. I wanted to show that page here. In particular, it's got the it's being updated, and it'll show the latest replications as they come in. And the blueprint itself, you can go to the Magrav's Power Blueprint download links, which is at the blueprint.keshefoundation.org/blueprint.php site. And just click on the first link there, the hybrid plasma generator, and you see the blueprint come up with the basic generator that's been sent to Washington for people to have a look at. And this is the one that folks should attempt to replicate, let's say. And then it shows the plasma capacitor design as well. Okay, well, maybe I'll quit talking for a while, and maybe we can have a look.
You want to pull up that capacitor design again, Rick? I got a question on it.
Sure, okay.
In the photo on the top left there, they show the aluminum and the wax paper or the parchment paper being rolled together. And sort of in the section on the side there, they show it parchment paper first and then aluminum paper on top. So there's sort of a conflict there. I just wondered if anyone knew with one way was the right way or not.
What came up in the discussion is like the photograph. You wind it like a regular capacitor.
I've never wound my capacitors like that with foil and parchment paper.
Well, if you look at it in electrical terms, if you simply have the paper wrapped around the pin and then the foil wrapped around the paper, your capacitor is incredibly small. It's in the picofarads. By wrapping the two together, you've got a tremendous amount of surface area there, and your capacitance goes into the microfarad range. It actually lowers the frequency of the capacitor dramatically.
Good thing we got an electronics guy here. Thank you.
Yeah, with capacitors, surface area matters big time. And the more surface area, the more capacity the capacitor will have. But they did mention during the demonstration that, or during the discussion, that this is the way he wound them. He laid the two papers together and wound them in alternating layers.
Okay, that's great. Down below, we got those Armin connections with a 90-degree bend, and I think Mr. Keshe said you lose over 50% of your plasma flow when you do it that way.
Yeah, you want to be careful with that. If you do have a wire coming through the Armin connection, like the pin going into the coil, you need to have that pin go past the coil and then wrap back on itself.
Yeah, so I just think that photo on the bottom it's misleading.
Well, the connections do work really good if you're careful with them, and if you design your system so that you don't have the coils bent at 90 degrees, if they're in a nice arc, they work considerably better.
Maybe that's why the one capacitor burned out, I wonder.
It could be, it could also be kid related, but we don't know yet for sure.
Yeah. Okay, well, that's interesting. Anything else about that? Go
There's
ahead.
been lots of questions about this lubricating gel. Some people think it's grease. Some people think it's KY jelly. Some people think it's petroleum jelly. And I think it was mentioned that it's not petroleum jelly. I didn't hear exactly what was mentioned on that.
It was
So
said that it was not Vaseline. Someone mentioned Vaseline as that's petroleum jelly. And
Yeah, he mentioned something about a gel that lubricates your hand, something like that. That's what Mr. Keshe mentioned. So I think KY jelly might be suitable for such a purpose, but we have to look into the ingredients of each specific gel before we use it.
yeah,
I
it
don't.
may be it may be as simple as lanolin, just regular old lanolin. We don't know yet. We need to get some more details on that.
I
Yeah,
asked
or
if it was
aloe vera.
I asked if it was glycerin, and they thought that it might be. I have some glycerin here. I'll just let me just show what it looks like.
Yeah, it looks like thick water, but it doesn't dry
Like
out. If you mix the glycerin with your Gans, then you probably will get a nice gel with it. I haven't tried that yet.
where did my video go? Oh, there we are. I just wanted to show, this is a bottle of glycerin, and you can kind of try to see the bubble inside. And it moves a lot slower than water. It's got more viscosity, you might say, than water, but it's also quite a bit thinner than. Well, it's about like a 1030 automotive oil, let's say, on a warm day.
Yeah, that actually looks very interesting because it would make it very much easier to paint the glycerin and Gans mixture onto the parchment paper, and it
Yes,
would ensure a very even coating.
that's what it's sort of used for. It's I found it in the wedding section of a craft store, and it's used for restoring the consistency of icing colors. So I guess the way I look at it is it will allow the nanoparticles or the icing colors to disperse evenly and keep them from like running off the side of the cake or whatever. It would keep, or in our case, it keeps the nanoparticles first of all separated evenly, and number two, it keeps them sticking to the surface so they don't just run off and all squirt out all over the place.
Rick, you add that to when you're making bubbles or you're blowing bubbles, you add glycerin to do that mixture too.
Oh, is
Remember
that right? Right, I remember something about that. And in fact, I got some. I did get some bubble solution here. This stuff that's really thick inside. Turned out some of it had dried out. That's what you get from the dollar store. But this is it's called touchable bubbles, and what it is you can make bubbles that you can touch. I believe it uses glycerin in them to form the bubble. It forms sort of a white film. It's also, I think it has alcohol as well, so the alcohol evaporates, it forms this film, and then the bubble stays without bursting. So I'm thinking, that could be really handy if we were wanting to create certain atmosphere of having these bubbles around, that you want to maintain the plasma vapor or whatever else you were enclosing in these bubbles. And perhaps the glycerin's another secret to help with that. But as far as the actual creating the plasma capacitors and so on, this stuff, it could very well work. I've also was thinking about, what's it called again? Gelatin. Gelatin might be a way to, it would start out kind of loose and then set up after a bit. It might be a way to, and also the sugars in jello, gelatin, maybe that would be a benefit to feed into the core with the CH3 or something like that.
I don't know, maybe some, actually, that wood glue. You might want to take a look at wood glue to see what it might do as well.
Well,
Possibly.
it occurs to me that you'd want a non-evaporative system. Like if the gel evaporates and turns into solids, your whole conditions are going to change.
Well, that's right. That's what I was thinking about. I've been thinking about that a bit. Almost like a silicone or some sort of stuff that doesn't, or silicon perhaps, something that doesn't tend to evaporate like water does or alcohol or other things like that. I'm not sure if the glycerin, if it's...
I don't think glycerin evaporates very easily. Maybe the alcohol content that would be in some glycerin mixtures might. I forgot what glycerin was made of. I guess you could look at it on.
Yeah, good to have a look at that. It's some kind of magical qualities, I think. They use it in labs quite a bit, I believe, for some of the pharmaceutical type experiments. Anyways, is there more we can say about that? There's something else. Oh, I just wanted to note, in terms of the glycerin, and in terms of all these fluids that we're talking about, my experience a few weeks ago, and I've relayed it a couple of times, just want to make sure people hear about it, which is the idea that, for example, it would be a good experiment to put some CO2 Gans, a squirt of Gans directly into the glycerin and see what happens. And I've noticed in my experiment with hand soap, which is a liquid hand soap, very much the same consistency of this, a little bit thicker actually. And I've put Gans into a container of the hand soap, and it's amazing how the Gans, the CO2 Gans, will just spread like a cloud and start, forming inside and wanting to expand out in the space. And then if I take some of that expanded out hand soap and squirt that in a bathtub, for example, and you watch the soap, the white sort of cloud it just wants to spread all into the entire volume of the fluid. And I thought that was interesting because CO2, usually if you were to put it into water, it'll tend to spread out a bit, but it also tends to just to slowly go down to the bottom. Where with the liquid hand soap, very similar to this, the particles stay like they seems like they repel each other. Maybe the charge is different or something, and they're more individualized particles, but they want to spread out. They don't clump together as much, and they don't just settle out on the bottom. They're dispersed evenly. And I thought, well, that's interesting. What a great way to prevent like hot spots on your plasma capacitor or other on the coils and that sort of thing. It should have something that disperses it evenly to keep the plasma even and have more consistency in our experiments, I would think.
You haven't done that with your glycerin yet.
No, I haven't. I just got this and I haven't had time to play with it yet, so I just happened to be wandering through the wedding section of the craft store. Actually, they have some pretty neat things. They have platforms for wedding cakes, and they have little stands for each platform, so you could actually build up a Magrav holding device out of wedding cake parts, if one wanted. Okay, so anyways, I think it's time maybe, if there's no other questions about that or comments, we can move to part 2 of our multi-part section. Guy is busy working over here. Let me do just a quick view of Guy over here, the co-pilot tonight. There he is.
Everyone.
And you see all the stuff on his desk there. And he just brought in tonight all these balls and rotating and motors and batteries and systems and stuff. And he's got all kinds of things that have just magically kind of fit together. All the screw threads are actually fitting and so on. So he's had a good day with putting together. You can see a bunch of
Trying
little,
to create
little reactors over there somewhere. It's hard to
dual
see.
core, a dual core with a ping pong ball. And I got a few ideas there I'll present later.
Right on, Guy. Okay, so if you hear some funny scratching noises in the background, that's Santa's little helper, Guy, in the back there, getting prepared for Christmas.
Scratch, scratch.
Okay, so maybe we move to Lee Coates, who has something that's maybe a little more relevant to today's topic at hand, which is the replicating the Magrav's energy plasma, what is it called? Hybrid plasma energy, hybrid plasma generator. So Lee, let's go to you there if you don't mind. Ooh, that looks, I have my thing in the way. That looks very interesting there. Of course, you'll have to tell us all about it. So, I mean, obviously, it looks like you've got 2 compressors. Those, just so people know, those black things.
Want to put my video up there?
Oh, I'm sorry. I have it on my live stream, but not on the place where it matters. There we go.
Okay.
Good.
Well,
Okay.
I wanted to get a quick start on this just to play around and see what was going on with it. And so I grabbed my old Magrav that I made back in November and just tried to see if that would work. And I sourced the big problem with this thing is to source the refrigerator compressors. So I went over to the municipal landfill and they got it's ours here locally is run. They got real cycling guys over there running the place and collecting all the metals and they're separating all kinds of stuff out. And went and talked to the guy and says, "Oh, no problem, and we can get you a compressor motor." So he took me back to the scrap metal pile that they were building there, and he actually took we took 6 of these. Actually, he took 6 of the compressors out of the fridges, and then we went back to the boss to see how much they're going to charge me, and they charged for 6 of them. It was $40 for, so $7.50 a piece. So I figured for to run the house, I'd need to have 2 systems, one on each phase. So I'd need at least 4 of them, and I didn't know whether they would all work or not. And then actually all 6 motors work, so I was lucky that way.
Yeah.
So anyway, I wired it up this afternoon to the old Magrav system there and turned it on. Got the compressor pumps are running and stuff, but it doesn't kick in and actually work as a generator. So I'm using the old capacitors here. I actually got 10 of the old capacitors on here, so that may be the problem. And the other thing is I left the matter state wires the way they came, so some of them are fairly long. And I'm just wondering, maybe I should be cutting these matter state wires really short and to get, or maybe I got to leave it run for a while till these wires nano code or something to get the things working back and forth here, because it's working in the plasma state. So
You do have those compressors wired in backwards with the hot going to the common rather than the live?
yeah, one's wired one way, one's wired backwards.
Okay, good.
Yeah.
You have a single wire that goes from the plasma capacitor to the one of the units. That's that one.
Yeah.
And I was wondering where that hooks up to on the compressor.
Well, the positive out of the Magrav unit goes to that connection there, which is the positive to one motor and the negative to the other motor, and actually the positive to the power bar.
Well, there's one wire that goes directly from the plasma capacitors.
Okay, capacitors that goes to directly to the negative on the generator. Capacitors. So one of these wires here, they're sort of. I got them. Which one is it? It's the black wire on the back. The pin's coming out. So it's this side here which goes up and this feeds the negative on the coil. So yeah, so the negative on the capacitors, the pin side goes to the negative on the coil, on the bottom coil here.
What's that theory behind the 60 hertz?
Well, Mr. Keshe explained it good on the 131 Knowledge Seekers workshop, but the idea is these form a infinity loop, and they go back, and you get a frequency back and forth between the two compressors. So, since I'm not sure I don't know how it maintains the 60 hertz. We feed it with 60 hertz to start with, but I don't know the electronics behind it or the plasma explanation why it would maintain 60 hertz.
Well, it should have Keshe talked about an infinity loop between them, and if the motors are designed to run at 60 hertz, then that'll be their natural place, their position that they want to be in, perhaps. And that'll be like the resonating frequency for that motor where it runs most efficiently and will be happy, I suppose. So it'll want to be running at that frequency, and it'll generate it because one of them is giving and one of them is receiving, apparently. So now let me just get back a little bit to that wire I was talking about. The one that runs from the plus of the plasma capacitor down to the connection in the pink compressor.
Okay, so the plus on the capacitor is on the back side here. It hits the switch here and then goes down to the common side of the motor and capacitor.
The common side.
Okay, it's showing here that it's attached to the start side, not the common.
Well, the thing is, you look inside these. I don't have 3 pins in there. There's a.
Do you have a capacitor?
That's my capacitor right here. That's the other thing. When you go to salvage these things, some of them don't have capacitors. They only have 2 wires coming out of them.
Right.
And then some do have capacitors. You'll see there's 4 wires, or in this case, there's 3, which splits into 4 a little further on. And that capacitor is mounted somewhere else under the fridge. So you got to make sure you get that if you're salvaging these things.
Okay, so
the blueprint, they're really specifying motors with start and run windings, and I would think that even though the start winding is disconnected once the motor is turning, you're still getting back EMF coming back from that, which could be feeding into the system as well. So it may be that we definitely need the start and run windings. Yeah, I would think so. I would think that would be important.
So I'm noticing that it's the one compressor that has the capacitor is the one that wire runs to from the plasma capacitor right down. Basically, it looks like it's to the terminal of the capacitor of the fridge.
Yeah, and once on the blueprint, the pink compressor, once it's up to speed, that start winding disconnects. But it's still connected through that capacitor into the circuit. So
It's
there's going to be
also connected to what's the PTC?
that's the switch that switches between start and run.
Okay.
Yeah, so you got the switch on the top,
So
which is a thermal. It's a thermal switch.
No, it's actually rotational. Once the armature reaches a certain speed, it switches over from the start to the run windings. That's why some AC motors, when you turn them on, they'll start to spin up, and then you'll hear a click, and then they go up to speed. And that's what that switch is. That's listed. That PTC.
okay,
Yeah, this one actually clicks sometimes, but you look on Wikipedia and you find out it's a thermal switch that does that PTC designation. So, but anyway.
Okay.
maybe
So I don't know. There may be like three wire connections to the motor in behind here. Maybe one's going through the switch, but it's not. Like this other motor here, you can see the actually right on the housing back there. It looks like there could be three.
can't see a little higher, and yeah, there.
In behind there's that little circular thing might have three wires. I had one other compressor here actually had the three wire connection like it shows on the blueprint, but the other 5 didn't. They had this other stuff. So it may be 3 wires there. Just maybe I'll have to investigate some more to see what.
Yeah, I was discussing this with Vivek. I think it was last night, and it occurs to me that the compressor isn't really like vital to the system. It's the motor that actually matters.
Exactly.
So if we could go to like a fractional horsepower that's wound and wired the same way as the compressor, we may be able to use just simply a motor. And I mean, the compressor makes sense. Everybody's got a fridge. Use your fridge, certainly. But for experimental purposes, I'm thinking just a pair of AC motors with the start and run windings, and use them as a cooling fan. We could go to a smaller, much more compact system, but again, in 2 weeks, we're going to have a completely different set of blueprints come out. So
that's true.
This is just an intellectual exercise at this point, really.
2 weeks or 2 months, I'm not sure which.
Won't be long.
Vince, can you go through that motor stuff one more time? The start run motor. Are they going to be brushless motors?
Do you mean Lee?
Was that Lee or was that John?
You
That was John.
You said Vince. You mean Lee?
And I meant John.
John.
Yeah,
Okay.
no, the
Sorry.
AC motors that we're talking about are brushless. They're like most AC motors are brushless motors. The rotor part of it's just a magnetic is all. Just fire series of coils around the outside.
So
Sorry.
how does the 60 hertz come in when you do that?
Don't worry about it. It's inherent in our system. It's just going to be in the system when you build it. The starter, the starter is going to pretty much matter. I would think that you need to spin that little magnet in the pump up to the same speed it would normally run with a powered by a 60 cycle AC. But then again, that's not really specified. It's not shown as critical. So it may not matter. It may be that once we trigger the system with that starter, it just balances itself out to what the motors want.
Hey, John, wouldn't a Variac do the same thing?
Nope. Variac is just a resistor. It's just a variable resistor.
Well, do you use a voltage control to change the? How do you determine the hertz? Is it the rotations of the motor per minute, or
Well, there's a number of different ways to do it. If you're looking at the blueprint itself right now, the yellow box in the upper right-hand corner is simply a starter circuit. One, all right, and I'll explain how that circuit actually generates energy, and then maybe it'll be a little more clear. There we go. Okay, if we're looking at that, where the inside that yellow box, we've got this 6 volt to 12 volt DC motor, and it's attached to a cylindrical magnet. And now that magnet is magnetized not end to end, but side to side. And if you get one of those magnets and you start playing with it, you'll find that over the entire length of the magnet, one side is positive, one side is negative. And when that spins inside of the coils that are inside that black box, every time the magnetic field energizes one coil, you get a pulse of electricity. And you're going to get a frequency depending upon how fast you turn that.
Well, some people are finding they have to turn it really fast in order to get the voltage out of it that they're trying to get, though. And I'm wondering if we need the voltage or just the frequency to make it work. They're having to go, like, they're only getting 20 volts or something at a reasonable speed, up to 5 or 10,000 RPM, and they're thinking they have to go to 30,000 RPM or more or something to get the voltage up, and that doesn't seem right somehow. It must be some
No, it doesn't seem right to
inefficiencies.
me either. And I believe what they're thinking is still in the matter state. They're still in the electricity aspect of this, where they think, okay, well, we got 110 volt motors. I need 110 volts out of my starter circuit.
I wonder about that. Now,
I don't think that's
can
accurate.
can
All we need
you
is
can you answer my question first? That can we just plug the switch into a 110 or 220 outlet to get this thing started? Like, why not just plug the fridges in, get them going, and then unplug them? Basically, can it? Is it? It doesn't work that way, right?
Well, that's what I'm doing here. Is I'm plugging that into that three-way switch. It's just house power here.
Right.
Okay.
So, what is the downside of that? Why does that not work? Why, or are we trying to make an independent system here that's totally off grid, so we don't have to do that?
It doesn't work off grid. That's the problem.
Well, it will work too for experimenters, though, to just plug in, then unplug and see if your system keeps going, and try something, and then plug in, see if it keeps going, and so on, rather than the whole starter circuit. Or do we need a certain pulse out of this starter circuit that's different than the AC pulse of 60 hertz going into it at 220 or 110 volt?
Okay, I can elaborate on this a little bit. I was involved with a fella named Gerard Morin in the Lower Mainland, and he was doing a very similar thing in a very different way. But he was using the little pump with a DC motor and a battery to trigger his system. And what we found out was that the output of that little the pump motor with the DC motor driving it was completely different than the AC system. If we hooked it up so that we had if we plugged it into the wall, plugged a power supply into the wall and used the power supply to drive the motor, which drove the pump to create an output, the system didn't trigger. It only triggered when we were independent from the power grid, when we were using a battery on the motor, which was very weird to me, and I still don't understand exactly why, but it showed that the output of the pump motor, when it's driven as a generator, has very different properties. And in his system, the way he was working with it, we were getting some amazing results. We were getting I don't know if it was the Keshe style plasma, but we were getting EM effects like you would not believe from the system that he had built. And the only way that it would work is if we drove it with an independent supply, a battery with motor into the thing or into the pump, and use that to trigger his system.
Yeah, that's a really good point. Really good point. I've heard that before, I think, maybe in the Bedini systems and some of the other ones. And also it makes sense that, I mean, Douglas apparently left the starter parts at home or whatever, and we're They were trying to improvise, and it makes sense. If they could have just plugged in and then unplugged to make the system work, they would have done that, as far as plugging into the grid to make it jumpstart it. But they didn't even consider that because it didn't have the right quality of pulse, apparently, to get the system started, I guess. So that's interesting.
I remember the discussion when they were talking about that. It was really quick and I was really tired. But I believe they tried a signal generator, which is a pure sine wave. You can tune it to 60 hertz. It's perfect. It's beautiful. It didn't work. They tried a inverter, if I remember correctly. Like you plug a...
Yes, I was wondering about that as well. Yeah.
And you can drive your computer off of it. But that didn't either.
Yeah.
So I think it's the very special kind of waveform / energy / magnetic interactions with that motor within that pump that's being driven by the motor that really matter in this system.
Well, I mean, think about it. What is it? It's a rotating actual magnet as opposed to just a electrical pulse. It's actually a magnetic pulse.
Yeah.
Which I think is quite a bit different than a electrical pulse. So
yeah, it all brings to me the switch. You need a very fast-acting switch, or move it really, really quick. You wouldn't want to, you want to be able to switch between the frequency of 2 pulses, I would think. So you'd want a fairly fast switch for this. But if we can spin this thing up and get, say, well, we were getting 132 volts out of the pump, and that went through a number of transformers, and the output of that was like we're in the 50,000 volt range, and then applied that to an emitter. This is the Jared Morin thing that we were working with. He's actually got a video about it, and the effects we were getting were completely different than the effects that I get when I just play with high voltage on a transformer. So there is something different about the form of energy that's coming out of this thing.
Interesting. Let me show you something I've got here and see what you think about that as a motor. We'll get back to you in just a minute there, Lee. I'd like to find out more about your system.
We're still spotlighting. There we go.
I gotta do it a little differently this way, and then do that, and that down, and put that up. Okay, I've got this thing I just had to pick up today at Princess Auto. It's basically a AC motor, okay, and there's very little resistance in it. It spins quite readily. I don't know if you can see there. It's spins on. There's no magnetic resistance as such, so it works on. It's got 3 wires going into the main body, and then a ground wire on it. And it's actually designed for 260 volts AC, which I thought was interesting. It's only a 100-watt motor. It runs on a couple of amps. And so I'm thinking, well, if it's a 260-volt motor, maybe at a certain RPM with perhaps a feed voltage going in to induce a field. I'm not sure if it will actually create a field as such without having some sort of induced voltage or magnetic interference or something there. But anyway, I'm ready to attach that to something, perhaps this other motor which I have here, which is a blower motor for a vehicle's heating and air conditioning system. And it's 12 volts, so I could hook up the 12-volt motor to my 260 volt output, and I should be able to have I don't know if you can see that, but they almost fit together. It's it could generate some kind of signal, let's say, that would be similar to the other, but I'm not holding my breath on that one. What do you think?
Do you know how that AC motor is wound? Do you know if you have the 3 wires? I understand they're there, but it could be a 2-phase. It could be separate start and run windings.
Yeah, I'm not clear on that. It could be three-phase. It does have a TP at the bottom. It might be three-phase. It's designed to run at 2870 to 3450 RPM, depending on the hertz and the voltage. It's actually it's got 115 volts as well on it here. So that's a little confusing. Why would it have 260 volts AC as well as 115 volts? It's got some sort of capacitor, 20 microfarad capacitance as well.
Okay.
Maybe it has a split circuit on it. Pardon me?
One you might be able to tell is do a resistance reading. See if you can find if one's common. One of those leads should basically be attached to the case.
Yes, the
And-
yellow lead's attached to the case. That's the ground for sure. So I got that one eliminated. There's 3 other wires that go into the actual inside. So
yeah, and
yeah, I'll be able. Go
probably
ahead.
a common as well. So if you check the resistance of that, it may be that the brown one goes to the case as well as a common. And then you would have 2 resistances, one on the black, one on the blue. And if it's wired correctly, if you measure between the black and the blue, it should double what you read between black and common and blue and common. If that's the case, then you may be able to use that motor as part of the infinity loop system in the generator.
Yeah, it could go either way, either as the starter circuit or perhaps as part of the infinity loop. So
Well, it's a pretty departure from the way the starter circuit is designed. We're not working with field coils. We're working with a magnetic field in a coil system.
yes, right. I'm aware of that. Yeah. Yeah, well, maybe it'll work better as, like you say, a refrigerator compressor A, roughly.
Awesome.
Interesting.
And motors in the compressors, they're just simple, basic AC motors. The compressor part doesn't do it. It just adds a bit of
it adds, pardon me?
Adds a bit of a load to the
Yeah,
system.
that's what I was wondering.
Mechanical load to the system. So why can't we simply use similar wound motors, but we could go with like a 150th horsepower motor and just have it as a fan?
Well, yeah, except
I was hoping
what I was thinking, I had contemplated that idea, and I think that there is a possibility, at least, that the pulse is what's important. I mean, we were talking about the starter circuit, for example, just a minute ago, and the pulse that's given off by this rotating magnet here that is different than just a rotating electrical field, let's say. So we go back down to our units here, and rather than just a rotating electrical field, you have the load factor on these. And exactly like you were just saying, there is it's not an even load while the motor goes around, because you have that little piston in there that's being loaded, unloaded, loaded, unloaded. So as the motor turns, it's got a load on it, and then it releases the load, and load on it, and releases the load every revolution. So it's got a pulse to that electrical load on the motor, putting inducing a load back in, the back EMF and so on is occurring because of that load on the motor for every cycle, is the way I'm thinking of it. And that may be important.
I wasn't aware they were reciprocating compressors. I thought they were vane compressors.
No, they are reciprocating.
There's a tiny little piston and valve in the piston, and it just goes up and down basically in a cylinder. It's the way I understand it.
Actually, it goes sideways. The electric motor's right at the bottom. It's a big sort of flat pancake motor, and then you got the compressor part head sitting on top of it.
Maybe we can have a blow-up look at one of those. Let's see if I can find one that's not got some kind of copyright on it here. Put the blueprint back up for now because it's...
There are a bunch of videos on the internet where guys are making compressors out of these and other stuff, and they grind the caps off the top of the compressor so you can see inside.
Right.
Some of these motors and compressors inside are sort of hung on springs. And that's why they're so quiet.
That's right. Yep. Where was that one I saw?
Lots of people are explaining how refrigeration works, but they're not ripping the compressors apart.
Yeah, I had a picture a few days ago. I'm just trying to find it again here. Where was it?
You want to search the guys who are making air compressors out of refrige compressors, and
Here,
some of those guys take the cap off, and you can see inside.
Let's have a look at this. Let me see. Share the desktop. Okay, this shows. Let's see, we got it both ways here. Yeah. Compressor. There's a blow up of the actual parts in there. So you can see there's a little piston right here and a connecting rod that goes down to the shaft of the electric motor. There's the windings of the motor. There's the shaft of the motor. And it's got a cylinder head and the whole thing. I couldn't believe it, actually. I had no idea. And the crankshaft, you know, discharge muffler, and the whole works all inside this metal container. So it definitely would have like some sort of pulse on that shaft for each revolution, I figured. Now when you think about it, these units are designed to run at 3,000 RPM. Okay, so that's 3,000 revolutions of the little piston for each minute. So each second dividing by 60, and what do you get?
200.
Well, if it was
You
36,
you get 50, right?
you get 50, because
Which
if it
is-
was 36 RPM, you would be 60. And so you're
3,600 RPM. Yeah, it would be 60.
Yeah, 3,600.
So I think some of these run at 3,600 and some at 3,000, I think. So the 3,000, to me, the 3,000 one would be putting out, if you divide 3,000 by 60, you get 50 hertz, 50 cycles per second. But if it was running at 3,600 RPM, divide that by 60, you get 60 cycles per second. So maybe you have to get one of these that runs at 3,600 RPM to start the 60 cycle systems, and one at 3,000 RPM to start the 50 cycle systems. It's a bit of a long shot, but what do you think of that theory?
Do you need a voltage regulator to change the speeds on those?
Well,
No.
If you,
They're-
same
they-
thing
they're-
with the motor.
they're usually
the motor,
no, they're usually designed to run at one speed, no matter what the voltage is. Right, John? Is that correct?
Yeah, AC motors are frequency dependent.
Frequency dependent rather than the voltage, you mean?
Yeah, you're with a lower voltage, you get less torque, but it should still run at the same speed if the frequency is the
Right,
same.
right.
Now, if your voltage is too low, you don't have enough torque to spin the motor, so yeah, it's going to run slow. But usually they just lock up and just vibrate. And that
Right.
happens.
So in this case, the motor won't even start until it gets enough power in the capacitor to get it to, you know, it has to have enough to enough oomph to get it started before it even starts the motor itself. So
Yeah, that's usually because it's trying to start against the load. That's why they have that the high current start windings to give it a kick. Once it starts spinning, it switches over to a run set, a run winding, and that keeps it up to speed.
right.
Which is why I'm thinking that if we have a simple start run winding type AC motor, I don't think the load is really going to make a difference. I don't think the compressor end of this, other than it's convenient because we have compressors already in our fridges. I don't think the compressor part of this is actually that critical in this system.
I don't know. I think it has something to do with the pulse, and also consider the idea, like they were talking about this infinity loop between the two compressors, and that one's giving and one's receiving, and that one of the compressors has its lines, all the discharge and suction tubes are already hooked up. They're part of the fridge circuit. The other one has them wide open. So we have two different conditions there. One is pulsing. The one in the fridge would be pulsing with the piston, whereas the one that's open, like what we see in the picture here, if the suction and discharge tubes are open, there's a lot less resistance on that piston, and it won't be compressing with each cycle as much. So it might be that, or I'm assuming that now that it might not be true. It might be actually more on this one because the air is not used to having that density of air going into its system. It's supposed to have its freon gas or something else in a vacuum environment. So I'm not clear on that, but I'm assuming that that would be the case, less resistance.
Well, the little bit of refrigeration that I did when we screwed up and vented the refrigerant, it stayed on the floor, so it's more dense than the air.
It'd be, yeah. Okay. So in any case, there'd be some variance between the two units in the way that they're in the way the if you look at the waveform, one of the motors would have more back EMF than the other, probably, in a different waveform, the way it handles the power, because of the way the piston moves up and down, I think.
Yeah. But I think for Lee's system, I think what he's missing on his system is that...
Let's go back to Lee's system and have a look at it there, now that you mentioned that. So.
Yeah, I think what he's missing is that very unique output from that starter circuit, because it is I can't explain why it's unique, but I know it is, and it does things that blow my mind, things I never would have expected.
I guess I gotta go to the fish store.
The fish store, pardon me.
The pet shop.
Yeah, and I'm of the opinion that the voltage output doesn't matter. It's the not the voltage aspect of the output. It's that very special condition within the waveform that is going to trigger the system. Because
Okay.
they've tried it with what would be, in reasonable terms, identical systems. They tried a perfect waveform. They tried an inverter, which is 120 volt, probably a true sine wave, I would think.
And they probably tried a pulsed, DC, I assume, as well, right?
Yeah, he says he's never tried pulse DC, but apparently he tried that and that didn't work either. So if we can figure out what that really unique output portion of that little spinning magnet in the coils is, we may be able to come up with a better trigger system for this.
Excuse me. Has anyone looked at a oscilloscope output on that circuit, that starter circuit, I wonder?
Well, we didn't when we were working with Gerard. He didn't have a scope.
That would be interesting to see, even though it might not be directly related to what we need in terms of the pulse. We might be looking at a plasmatic pulse, a Magrav pulse, which is still hard to measure in a way.
Yeah.
Okay, what else can you tell us about your system there, Lee? Is there anything other details you want to discuss or show us?
I guess when I build my new, like I got coils in the capacitor parts are in the nano code bucket right now, so it'll be in there for another 3 or 4 days, 5 days. So when I build the new system, I'm going to make a frame out of the plastic pipe and do and coat the inside of the plastic pipe stuffed with plastic chips and stuff, and try that. And so I got that started. I haven't finished that, but other than that, I just threw it together quick today and figured I'd show it anyway, just for get the discussion going here, and that's
Right
helped a
on.
lot.
Yeah, and I'm
So
sure it'll help people like the person that was complaining in the forum that Mr. Keshe gives us these designs, but they're so expensive to build. Sorry, there's someone with a microphone open. Pontus, could you please keep your microphone muted? I've had to mute you already a couple times there. Excuse me. That the big sort of secret here is, like I was saying, there's a person was complaining in the forum that, oh, this is so expensive to have to build these systems, and I will have to go out and buy a refrigerator for $100, and it's going to cost $300 just in refrigeration equipment in order to buy these parts and so on. And here you've gone out and how many of these units? You get 6 of them or something for 40
6
bucks?
or $40.
So, I mean, potentially, if you could, I mean, if it all works out, you could build 3 systems for 40 bucks, plus, of course, your Magravs and so on and so forth. But these are the most expensive parts, probably, of the entire system. I mean, to get...
Well, copper
To
wire
see-
costs more, but
yeah, I mean, but to get the potential...
Lee lives right. You see, Lee lives right. He's blessed because he can just walk out there and things just happen for him.
Yeah, well, speaking of which, Guy has that same touch, you know. He walks into the thrift store and they hand him some piece of gear that's just exactly what he needs for some experiment and at a very reasonable price and so on.
I'm quite lucky, yeah.
Yeah, he's an excellent lab parts getter. It's a special touch set for that sort of thing. You have to be able to keep your eye open for things like when you walk into a Home Depot or some other big box hardware store or something, and suddenly you see something that's been used for centuries for the same use, but you have a glint in your eye for a new use for this, for some reactor combination, you know. And it's repurposing the things that are in our environment and in our faces already literally. Like I was telling the story about Guy, and well, yesterday, was it, or day before, I was over there and sitting down, and we were looking at the diagram for the hybrid plasma generator and all the parts. Guy had it up on his wall, and then he was thinking, geez, it just seems so complicated, so many parts and so on. And I said, just break it down part by part and just have a look at this. I mean, you've already got your Magrav coils here, right? And yeah, he had those, check. And then we looked at the starter circuit, and it turned out he had an electric motor. Yep, he had a pump. In fact, it was running there right in front of me, and all these hoses running with liquids going through them and stuff. Looks like a Frankenstein lab with all these pipes and hoses. Yeah, he had his pump there, and he had a battery, and he's got a battery charger for all ready to go. And in fact, he had several electric motors. And so that part was pretty much handled one way or another.
Yeah, and the people that I work for got rid of little fridges, so I happen to have 2 little fridges just there sitting.
Right, that was the other part. It's kind of funny, actually, that I was sitting in a chair and just staring over at where Guy was sitting, and right beside him was sort of, a table that he had a bunch of stuff on, but it wasn't a table. It actually was a short little refrigerator. So I noted, And you also happen to have a refrigerator here, and what's beside it? Another even shorter refrigerator. I just laugh because Guy had all the parts, and then the only part that was left out of the diagram was the plasma capacitors. And I said, so all you have to do now is build the plasma capacitors, right? That's the only part of the circuit you don't have. And then he walks over and brings out this box about yay big, square box, a cardboard box, opens it up, and it's this huge capacitor, like about this big. And it's all glimmering in gold dust and so on the outside, plastic, beautiful, beautiful thing, two big insulated terminals on the top. And it's the kind you use in these new stereo systems, a 2,000 watt stereo system or whatever. It has to have big capacitors to jumpstart the system when it starts up, so it doesn't drain your battery and fry your cables and stuff like that. So he's got one of these huge.
Yeah, I got that one. I got
it's probably
that.
worth a few $100 or something.
Yeah, I got that one for $10 at the second-hand store.
$10 at the second-hand store. Nobody knew what it was, and then besides that, he's already got the plasma capacitor that you built too, or something, or at least you got all the parts there. You got all your GANs, you got all your coils, you got the nano. He's got everything he needs to build the whole system right there. So we were both kind of astounded that it was right there in front. The answer is right there in front of us, literally the whole time, basically. So
I'm gonna give it a go too. So I never done that in my entire life. So it's quite new for me. It's a big endeavor. But since I got everything under my hand, okay, I don't have much excuses right now.
I'll show you. Guy can say that.
I don't have much excuses right now, so I shall put my system together too and do my best as a amateur that never done that. I trust those guys like you, and I got the best guy beside me that's gonna help me just for my kinks, and Mr. Fix-It Rick. So anyway, here I hope you guys gonna keep helping us and supporting us and telling us all your understanding here, and put it into maybe layman term, like guys like me, or even there's probably a lot of people that don't have much expertise in electrical engineering and much of these things, and how can we do that for very little dollars and still have fun doing it safely and learning with the big boys. Actually, that's how I'm personally. I'm just an eternal beginner that keep growing. And I amaze myself these days of playing with all these. I never actually in my entire life thought that I was to do things like this, and now I'm enjoying it.
Right on. Okay, so
I got a question about hooking this thing up to the house panel.
okay.
I'm thinking because we got
Sure.
two phases coming in, we need two of these.
Do you want to show what you got in front of you, or should we show the diagram maybe so we know what we're talking about, where it hooks up?
Yeah, I had to move upstairs because my battery was running low on my computer. So
okay. Well, I can bring up at least the diagram, and we can maybe go with that. So you're talking about the on this unit where we hook up to
well,
what?
I want to, have independent power in my house eventually here.
Right.
So, instead of the power bar there, you'd plug that into the panel, or plug it at the panel. And we got two phases in the Canadian system, so we'd have to have two units, one plugged in each phase. And then my question is, what happens with the 220 volt appliances in between the phases if we got the main power switch turned off? How does two of these Magravs give us 220 power, or do we have to have a separate sub panel when a third Magrav for at 220?
We've seen in a number of demonstrations, the latest ones that I know of are down in Peru, where they've got 110 and 220 plugged right into the same power bar, and they both operate just fine. Your devices in your house don't really care about phase. They don't care which phase you're on. So if you're disconnected from the grid, you could just combine the two phases and have one single Magrav system running the whole setup.
Well,
Yeah, but
the thing is
but
with
with the 220 on our panels, we're going from the two hot sides of the two Magravs.
right. So the phase is usually opposite in that case to enable
Well,
the
they're
220 between the peaks of
they're
the
each
waves.
120 degrees out of phase. Yeah.
Right.
Yeah, so with your 220 devices, I would think that just simply rewiring the plug they're plugged into, so that you're not you're not putting the two sides together anymore. It should work just fine. The Magrav power is going to supply whatever your load requires,
So
and whether
instead
it's 110 or 220, it shouldn't make a difference, because we've seen, like I said earlier, we've seen 110 volt and 220 volt devices plugged into the same power bar, and they both work just fine.
okay, so that means in the panel we'd have to move the breaker down one notch so that it's all on the same phase instead of going across for the 220.
Would you have to do it there, or would you have to do it at the plug? I'd have to study
You
the
can't do
system.
it. You can't do it at the plug.
Yeah, I'd have to look at that system a little more carefully. I haven't really delved into that, but it doesn't appear to me that this is going to be all that complex to do.
Yeah, I was just trying to think. What if I wanted to turn? Once I get this running, I hopefully I won't have to run on the grid, but I don't want to change the panel so that I can't turn the main breaker on and run off the grid.
Yeah, well, think of it this way: if you've got two Magrav systems and your devices are phase dependent, how are you going to phase the two Magrav systems so they're 120 degrees out?
Yeah, that's what I was wondering. Mm-hmm.
Yeah, well, that was sort of part of my question, or my question in the background. It's only a problem with the 220 volt appliances, but
yeah. So it occurs to me it probably doesn't matter. We might have to rewire a little bit of our systems, but I don't think it's going to be that big a deal.
Anyway, if you hear about anything about doing that, let us know.
Mm-hmm. Good point.
Well, that's something we're going to have to address fairly soon down in Peru, because Dave he's got Magravs all over his place down there, and it's all 220 down there. So, and he's also got 110 volt devices. Daniel's brought down hair dryers and stuff like that. They just plug in and it works. So we may have to address that down with the group in Peru right away. We need an electrician down there who understands the Magrav system, and the technicians that they're working with aren't quite up to speed yet.
Yeah, keep us posted. Into the future, we got to get electrical engineers who can design buildings that for Magravs. Is there any push to get any electrical engineers up to speed, or courses for them to take, or
Not that I'm aware of. From what I understand, we're going to be moving into wireless really, really soon. And then it doesn't matter. You just have a unit in your closet, and whatever device you flip the switch on turns on.
Yeah, well, I'm a commercial construction guy. Okay, I've been a superintendent for 30 years, and of course, everything has to be signed off by the engineer and designed by the engineer. And I'd love to do a commercial, plasma power building.
Yeah, well, if you do it properly, there's no wire.
Well,
you don't wire the building. You just put the Magrav in the central point, and everything just works. That's what the wireless system that's coming up next is all about.
Right.
Okay.
So this will be the challenge: is to try to get, like, for example, if someone is ready to produce this system, it has to be certified first. That'll take quite a bit of time. By the time that happens, the next system will make this obsolete. It'll have to be certified, which will take time. But then the next system kicks in even faster than that. And the system is going to get kind of jammed up with the certification, because the time frame for the new improved devices, eventually going to wireless and at full power, it's going to be hard for the approval authorities to keep up, I think. And there's going to be such a huge demand, especially if there's any problems in the culture that demands that people need their individual power rather than it being spread through the mass ways they are now through the wire systems and so on, which are extremely fragile for natural disasters and various things. So yeah, it's going to be a challenge, that's for sure. And it's up to the Keshe Foundation to be right there and challenge the powers that be to keep up with this kind of technology, I think, too. So it's up to us as well as experimenters to show and tell and keep the interest and pressure on that we want this. We want this. Here it is. We can make it happen. If we can do it, then anyone can. And that means the authorities have to pay attention then, because they can't stop it. There's nothing to stop. It's just everyone wants it and we can do it. So we're going to. Let's change the laws and get on with it, whatever it takes. Anyway, I noticed Mark had a video open earlier there with some sort of electrical looking device. Do you want to pop that up again, Mark?
Hi, Rick. Hello. Hello.
Hi, how you doing?
Hi.
Do you want to share video for a bit, or?
It's just an old motor, and I had just a question for John. I
Okay.
just don't know what that armature was that was sticking out, but I think we're gonna, like you said, we're moving on faster than that.
Well, I don't know. Motor questions are kind of good right now, just as because they came up, and it is something that there's going to be lots of motor questions probably in the next while while we try to figure out what the best way to go with this. We got 3 motors in this design, which is kind of unusual in that sense. We're trying to move to less physicality stuff, but at the same time we got these 3 motors. So, and we're also told that things are going more solid state in the next while as well. So, but you know, it's an interesting mental exercise as well as Pontus. Your microphone's open again, and we hear a bunch of noise there. Okay. That once again.
I can show, like Denny. I really wanted just to show this little thing that I finally got it put together, and it's off grid. It's off of our whole. We're inventors, so I invented this. It's not what we should be talking about the generator, and I don't want to show it. That's why I don't want my video on right now, because if you want to stay on topic, then I'm far off topic.
Well, this group tends to be pretty far off at times, and as far as not far off, but far out there, let's say, we range a little more than the topic. Although it's nice to be able to keep on topic. We'll return back to the topic as we go here. I just saw that you got something interesting. It looks good there. Let me bring it up. Yeah, we're not sure what it is, but it looks really cool, so we got to show it. Absolutely, Mark. This is beautiful. What is it? It's beautiful. What is it?
That's what he was working on for the last several months and the last 2 weeks. He can't just stop. He's got to keep going.
That's right. These this is definitely a very interesting shape. I mean, you got these interlocking structures. Almost seems to have a sort of a male-female or at least a giving-receiving kind of relationship here. They're definitely not the same, right? Even though the spheres are technically the same size, I presume.
Yep, they're the same size spheres, but I put a lot of conditioning, and me, Denny, I worked did a lot. They were outside for a while. They had sugar. Some had salt. Some has nano. Some has non-nano. Some have bigger coils. Some have upper coils. Some have lower coils. Some have rings. I have I have everything written down that's inside the containers. I have all the pHs. I mean, it's really complicated, but it's pretty simple. And you know, we were trying to learn that the natural way. So I just put everything together Monday or Sunday night. So really, nothing's really happening, but some things are happening. My very first observation, I live in a basement, and the climate in here is relatively consistent, and it's been sitting here now for probably close to 40 hours. And I don't know if you can see it, but vapor, moisture is starting to build up on different areas of the top balls, and these are sealed. They're complete. I have screws in 8 different sections holding them together so that it's not perfectly airtight, but you know how plastic gets once you start squishing it together, it pretty much makes an airtight seal. And then all the holes that I drilled in have rubber grommets on them so that nothing can leak. I have down here too, there's a nano ring on the bottom, non-nano, non-nano large, nano large, nano ring on the bottom. I mean, it's kind of complicated, and you know, probably we could take a lot of time talking about it, but it started anyway. I'll let you ask me some questions.
Okay, any questions from anybody on that? Could you say what the fluids are again inside the main body of the reactor?
The main 2 fluids are, if I could probably hear, we'll take a quick look over here what I did. Here, I'll give you a little song. Dun, 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 dun. One second here. What do you think, Denny?
It's pretty wild. I think.
I am wild. So do you want me to show the little motor thing that I had here, or do we?
Yeah, that and the thing of it is, I don't know your direction. You got something going, but I don't know what postulate you had to.
I put a lot of things. Well, here anyway. So in those containers, in the little rings that I had, and I could get a little closer, but I had to make different ganses for everything that's in there. And when I first started out, these are 6 basic ganses. So what I did was, in the 2 units, I broke down our basic ganses in 3 sections, or 2 sections, but 2 sections of the same type. So CO2, CH3, and CuO. CuO, CO2, CH3. So now I have 2 different variances in these. Maybe not, but they have all of these have different pH values. I mean, now, and then I really learned how to use my pH stick. I called the company and I says, man, I'm not getting right readings. He says, well, are you doing blah, blah, blah? Oh, so you should be doing this. You should be gauging it every time. I says, oh, really? He says, yeah, then you'll get a true reading. And you can just go and get it, and it's pre-mixed up to pH 7. So every time I took a reading now, you calibrate your pH sticks so you know exactly that it's, and then you have different levels. So once I started out, you know, like now I'm taking readings on just about everything I have, from salt to sugar. I got different types of sugar that I made different ways. I have some nickel. Nickel's so high in pH, it's 12.5. You know, some sugars are 3.7 to 3.9. And then here my pH resistance, I think this is supposed to be gold Gans. And that's maybe what we should talk about the most. And it's almost a perfect pH. It fluctuates just a little bit. I wash it, goes from 7.2 to 6.8, back to 7.2. And it was a simple process how I did it. And here's the little 1 gram pure gold piece that I bought, it untouched, 99.9% gold. I treated one side with caustic solution. I didn't leave it in the caustic solution. I just dipped it in, let it dry, dipped it in again, let it dry, dipped it in again, and then I let it dry overnight. And then I started the experiment. Then I just put these two pieces in some my salt solution, and I ran it at voltage. I started it at 0.25, and I ran it for a while, nothing. So it actually only started to give up something at 0.00, which was a little bit less than a AA battery, because a AA battery is 1.50 volt. Correct? Do I have that correct? Okay, so that's how I made the gold Gans in the salt solution. Once it started to give up, it just was beautiful. It just made a nice, beautiful gold cloud. I made a video of it. I don't know, it wasn't too clear, but I put it on the Golden Age of Gans on Facebook. So then you could tell that it was almost done. It wasn't giving up anymore because the cloud sort of separated from the top and started to go down towards the bottom of the container. So I said, well, it's not giving up anymore. It's done. So then I just finished that part off. And then I took that salt solution and then put it into this container. And there was probably half of this container, which is about 200. I started off with about 250 milliliters from this container of just salt, and then I added another 250 milliliters of just CO2 Gans, and then that's how I started my washing solution. I'd wash it. I did the CO2 Gans the first, and then I started to distill. I did twice, 1 Gans, CO2 Gans, and 2 distill. And this is what I have right now.
Mark, you said you added CO2 Gans, like 100 milliliter or a couple hundred milliliters or something. Are you talking about the Gans or the Gans water? Was it actual
yes,
Gans?
The Gans water.
Okay, clear. Thank you.
Just to wash it. Just like Jackie said, when he washes his stuff, everybody, it's just the clear CO2 water, and that's been washed several times too. So you really want to wash all your main components a lot before you do anything. So this is what it's come up with. I don't know, can you?
Yeah, let's get a close up there if you can. Okay, can you tilt the bottom up or down or something? You can sort of see there. And what happens if you just sort of shake it up a little bit, just spin the water a tiny bit to see if it pulls up right away? Or oh yeah, look at that cloud. And it looks like fairly large pieces in there, or not pieces, but conglomerations or aggregates, you might say.
So I don't know.
Beautiful.
So it's as pure, and I stuck my finger in it, and it doesn't taste salty. It's just as clean, and there's no bitterness or anything. So
would you call that as sort of an orangey color, or what does it look like to you in real life there?
It's
sort of a burnt orange.
It's orangish, goldish.
Mm-hmm. Yeah.
Can I get it? Will the camera focus?
It's not too bad. It's just hard to get all the details.
Tilt it a little more?
Yeah, maybe tilt the bottom up or down a bit so we can see it one way or the other. Yeah, that's better. Nice. Beautiful. I think I've seen other gold Gans that's been created with that color.
Really?
Gold can be different colors. I mean, gold in the nano state is not in the Gans state normally, but you can buy gold in the nano state, and it depending on the size of the nano will give you different colors. It could range anything from green and purple and blue and
It's
red
funny you
and
should
so
say
on.
that because when I was making it in the little container on the nano side, and I said it in the video when I was making it, it was almost kind of like bluish black on the nano side. I went like, oh man, it doesn't look good. What's going on? Because the cloud of this stuff was staying on this side where the pure, the pure gold was. So then I thought, oh, bummer, man. I don't know what, maybe I had it too hot. And then I turned down the power. And I thought, oh, did I burn it? Did I do something wrong? And then once I started to wash it, I never seen any of that again. It just went away. I thought, oh, well, cool. And now this is exactly what it ended up like.
Nice.
Yeah. So, and then all this other stuff back here, there's like, like I had carbon and chrome and titanium, but I didn't really use any of those in the bowls. What I did in the bowls is I used the top layer here of this stuff. And I made a Gans of my own self here with my hair and nails, and then I just washed it with CO2. Well, I broke down the hair and nails with Peter told us, that this CH or the CH hydrochloric acid, the same stuff that's in our stomachs. In
HCl, hydrochloric. Yep.
Yes, HCl. I just got some of that. I just went to the health food store and I got they come in capsules, 650 milligrams. So I broke them open, 5 capsules per 100 milliliters, and I just I had all 10 of my toenails and 10 fingernails, and I took hair from the very top of my head, and I just let it set in there for about maybe 2 weeks, and it finally broke it down to where there was nothing there. And I just started washing it with the CO2 Gans, and that's, what, the other, I don't know if this was the dancing Gans. Yes, it is. It was the dancing. Remember I had that container where the stuff was just actually coming up through it a couple of weeks ago? Well, this was it. And it won't do it again. I mean, it will a little bit. I don't know if you said that the heat transferred through my thumb. And the particles were coming through the Gans. You could actually see it. I can still do it a little bit. And there's like the gold Gans will do it if I hold it long enough. It's really fine. It'll make like it'll push through. And I think it's because of the heat. Remember, I put the light bulb underneath it, but I haven't had time to do anything else with it.
Yeah.
So,
okay, cool.
I don't want to take up too much time, but it's a start. It's a no motor start. So I start to see a little convection in the balls back here, and
a no motor start, a no starting motor, and no motor start. Yeah, well, that's interesting. If you can, ultimately, if we can make it work without all these motors that are rotating and so on, and without the least physicality that we can get away with, and the fluids seem to be on the road to a more pure plasma state than the physicality metals and so on. But we'll see. It's you have to start getting some effects of things, of course, and it's all good and it's all fun until you need to get off the planet. And is it going to work or not? That's the question. But it's great.
Kind of report,
I think a lot of it is just in sort of the geometry or the effect of what we see. And as soon as I saw those spheres that you had there mounted on the legs, they look. I know it reminds me of War of the Worlds. The alien craft that land with the long legs and so on. Well, it's kind of, I don't know, it's got an alien look to it, definitely. It's very sort of high tech
Don't
and
ask me.
alien.
I'm a painter, so it just came to me. I didn't
Well,
have.
this is the thing that in this kind of science, it's more important to have the intuition of a painter or a poet than it is to have the mechanical knowledge or scientific knowledge of a PhD scientist. It may not help in this kind of technology in a sense. Once they get their head around it, then they can probably run with it. But to get your head around it when you're classically trained, and a classically trained electrician would have a hard time getting his head around the new plasma reactor, just looking at the wiring that's to him, an ordinary electrician, it would look like the wiring's already fried, and there's no chance that any part of any of this circuit's going to work because it's all fried to start with, and you use
especially if it looks black.
Yes, black means that's what I get paid to replace. And the first thing he would do would be replace all the wiring that was black, all the coils. It would be all fresh and new if it was a trained electrician.
Underwater in tubes.
Yes, water and electricity. You're mixing water and electricity in this paste that's and nano and frying everything, heating the wire before you even use it. Are you crazy? I mean, it's all completely counterintuitive to an electrician and counter to his knowledge and so on. The same with scientists, the same with virtually everyone in our trained culture of science, because we've forgotten so many things along the way, as we've demonstrated before in this teaching in this group of the what do you call it, the Hawkesbury was it? Hawkesbury device.
The Hawkesbury device.
Hawkesbury device, the first rotating plasma, essentially.
Right beside you.
A rotating sphere. Oh yeah, right. I mean, this is what's already been forgotten. We have these spheres in front of us here. Let me just show briefly that this is the, I can't see, there we go. The Hawkesbury device. And what it is you see this fella over here.
You can get off my.
Yeah, that's right. I have to spotlight. I forgot about that. And then I have to get it onto the second screen. There we go. And back to spotlight. Okay, so let's try that again. We have this device here with two people are operating it. And what we have is this guy here is rotating this big wheel. The big wheel has the a cord going over to this little axle over here, and on this axle is a sphere, a glass sphere. So it's a fairly large glass sphere that this woman is holding her hands on while it's spinning. Okay, you get the drift here? So this guy, this is the house slave here, and he's rotating. And this is the mistress of the house, and she has her hands on this glass sphere that's rotating at a fairly good speed. What's dangerous about this picture? No, but what's happening is this sphere will start glowing when she puts her hands on it when it's rotating, and that's the Hawkesbury effect. Hawkesbury was the assistant to Newton, Isaac Newton at the time, and Newton and Hawkesbury figured out this effect that was happening because people were running around the streets with mercury-filled barometers and so on that were quite long, had a vacuum sort of inside because of the mercury, and when it jiggled, it would start glowing. It would get off little bursts of light, and so they figured a way to partially evacuate a sphere. And the partially evacuated sphere, when you rotated it and touched it, the very act of the friction on the sphere was enough to ionize the gases inside and create a glow. And so this is a big phenomenon. They go around from town to town when it first happened and give demonstrations, and people were all in awe of it. And then they had home units you could set up so the wife could stand there and hold her hands on it, and the man of the house could read his newspaper by the light of this lighting globe. This is back in the 1600s, wasn't it? Early 1600s, I think it was. And the first form of electricity in Europe, in the Western world. And the thing about it is, it's a plasma globe. It's just like a plasma ball, basically. It's ionized gases, glowing, nice purplish glow. And the thing about it is, they didn't know what to do with it. They had no batteries and no way of storing the electricity. It was only glow on demand, basically. You had to rotate it to get the glow. So there was no other way to do it other than having some slave or a horse or some animal, I suppose, rotate this globe. And they couldn't even put it in a battery because it took another decade or two before batteries were invented. And then once batteries were invented, they started a whole different direction in the whole thing. No longer used plasma, no longer had a need to create the plasma. They had electrostatic machines that could draw the power of electrostatic directly, and then more electrochemical batteries and other types of machines to start generating power and so on. But the thing is, this is the first form of electricity. It was plasma, and they didn't know literally what they had in their hands, because now we're starting to go backwards, back into plasma again, becoming important. It's one of the most important key words in the whole world of science in the last decade. So it's funny that it starts out this way and it's returning back to that way, and now we see globes, people have globes, and we're all working with plasma. So there you go. It's I think it's interesting that many of even the parts we have in this new the new diagram that we've seen. Let's maybe just bring that up again here if I can find it.
Still got a question from Mark, but I want to see your diagram. The thing I had with Mark is that now if you push the balls farther apart and stood between them to see what kind of reaction they have on you physically.
Okay, we can have a look back at.
I haven't done that yet, Denny. Like I said, I just got it together, and there's a lot of hope. I have 9 rings, small rings inside the spheres, and I have larger rings on top and bottom. So and the reason why I made the spheres for different heights is for that reason, so that I get that crossover. But I think that this is going to take a while for the fields to build up.
Okay, thanks, Mark. And I have questions about this diagram that you have, Rick. Not so much about what's going on, but the whole process of having the 60 hertz and having the 2 compressors. Is it supposed to be that you're trying to fire up these plasma capacitors? Is that the reason for all this add-on, is firing up these plasma capacitors so that they send the power through the Magrav coils? What's the actual principle behind this?
Well, for example, we could maybe do a little playing with drawing or whatever here. Find a color that they didn't use. It's hard to find. Well, we can just use pink. Okay, well, the idea is that it's a plasmatic circuit, is the way I understand it. I don't know if I don't think that the plasma capacitors in themselves are the most important element of the whole circuitry. It seems like it's a, excuse me, a coordinated effort, you might say. Mr. Keshe said it was a combination of, I think he said, 4 different systems. So, I mean, of course, we've got the one that's outlined here, the starter circuit, and we can sort of understand how that works, and we know that it's important in its configuration is special. It's not just something you can plug into the grid and get away with jump-starting the system with the grid easily. So you need this little combination to give it the right impetus to start, which gives us some clues on to how the system works. Now, the other important thing I think that Mr. Keshe talked about the refrigerators as being part of what he called the infinity loop here, what's known as the infinity loop. These when they start kicking in and working with each other, somehow they interact, especially the connections are positive to negative and negative to positive, essentially. And he talked about one being the giver and one being the receiver. I'm not sure which is which here, if one is giver, one is receiver that way. If someone has some indication on that, I'd appreciate it. But in any case, one is a refrigerator compressor A and refrigerator compressor B, which has a capacitor in the one that's the B. And so somehow this interaction, not just in an electrical way, but in a plasmatic way, ends up feeding into the circuit, which if we take out the starter circuit right off the bat, afterwards, let's assume the system is up running and the refrigerators have started and it's in resonance. This switch is now switched over to the other way rather than the A-B connection. We now bypass the whole starter circuit. It's out of the loop. And now we have a loop that includes through the switch and this point up here, we have things going that way, as well as there's this, what seems to be a pulse line going into the plasma capacitor that runs along here into that same point up here. But on the other hand, this infinity loop is also directly connected to the power strip through these through its connection here, the plus and minus on the wiring. So we have an infinity loop that's part of that system, and it seems to feed into more or less a circular sort of system here, that if you look at everything ending up going to the power strip eventually, then it's sort of a circular system with this infinity loop circuit feeding into it. And I think it's kind of interesting. I mean, we have the Magravs. We're aware of the Magravs and units, the coil units at the bottom here, which are stacked on top of each other, and we've seen those kinds of units before. We've seen the basic Magravs units before, and so on, the power units. And we know that they don't normally run just by themselves. It needs some kind of trigger in order to produce that back current, that back plasma current, you might say, plasmatic field that seems to push backwards toward the grid rather than the power coming from the grid. So it seems like, in a way, this is almost like a superconducting circuit, you might say here. This whole round including the plasma capacitor, the Magrav unit, the circuit, the switch, is like one big round circuitry feeding in by this figure 8 infinity loop, which ties into the main loop in the same way that the starter circuit also ties into the main loop, at least in a temporary manner, sort of like, you could say, pushing the magnetic plasma around the circuit to sort of get it going. And I'm wondering if, like, in a
when
way,
they used to start their airplane motors, they'd put that little
good point.
shot in there, and then
Yeah.
well, some people would have to. There's different kinds, but they used to have one where they dropped in some kind of an explosive into it, and it would turn it. And again, another time they just turned the propeller to get it to flip over.
Yeah, and then what it reminded me of, and of course, if you think about it, Mr. Keshe might have thought in this way, is the thing at CERN, which you have a big circle, which is important, and it has different things feeding into it and out of it and so on. But it's important that there's an injection process into the circle. It's got a starter circuit. And I think with CERN, it kind of looks like this, and there's I forget if it's counterclockwise, there's another unit down here that injects into the main circle, right? And then there's another circuitry. I thought there's something else that ties into it that also feeds into that, or I know they have a number of ports they're able to feed out of this as well, where they have targets that you take the energy out of it, which is like the power strip basically. So essentially at CERN they have a power strip takeoff point where they have a look at what they have coming out of their system. They have an injection system to create the flow through the superconducting coils and magnets and the billions and billions of dollars of gear they have hooked up. Maybe the injection goes the other way around. I'm not quite sure, but I'm
that
thinking,
power strip right there, that first one. Oh yeah, there's only one there, but that power strip is more like a junction box where things are in parallel. All the negative side is all negative, and all the positive side is all positive. It's more like a junction box, I think, because your compressors, the positive and negative, is run over to that power strip as well. It's this diagram might be better served if you could draw it a couple different ways.
I got my, just a second here.
Can I put in a tuppence worth?
Just a second, I'm trouble with getting my picture out of the drawing here, which has suddenly showed up. Okay, there we go. Sorry, go ahead.
Yeah, Rick, I'm just looking at your diagram here, and I haven't been having a think about it. The two refrigerators that he's got a the top one is an inductive motor, and the bottom one is a capacitive start motor. Between the two of them, he's making up an infinity loop.
Sorry, we got some. Is there a call coming through or someone there?
There's a phone going through. My wife's just answered it.
Oh, okay. Sorry, I thought it was some other line.
Sorry about that.
Go ahead again.
Just to let you know, my name's Bob. I'm calling from Athenry in New Zealand, and I've been following this quite a bit.
Okay, so you were saying, you were saying there was inductive motor, and the capacitor motor. Now continue from there. I missed that part. Mm-hmm.
So what I'm doing with mine, I've instead of having refrigerators on it, I've just put in a straight inductive motor and a straight capacitive start motor into my Magrav, and the way when Dr. Keshe said when you start it up and throw your starter on it, he said you listen for the click. Well, the click is the PTC relay. So once it starts to activate, it clicks the relay, which disconnects the capacitors and all that, and then it runs as a simple inductive motor in both cases. And the way that he's got them configured, he can get with the feedback lines in the red and the black going up through to the capacitor, he gets his feedback into it, which then self-powers it. Now, the actual starter that he's got there, I think from what I can see, the whole reason of that is purely to get the pulses into the circuit of the capacitors and the motors to start that pulsing, which then will give it the energy to release through the relay into the inductive mode. And at that point, you disconnect the starter from there. Does that make any sense to you guys?
Who's doing the drawing? Is that you, Bob?
No, it's not me. It's
I'm having trouble because I can't move my screen, and I've got my picture in front on the live stream instead of the thing, and so I got to do a stop sharing or something here to sort things out. Okay, there we go. I'm going to move this out of the way. Holy cow. There we go. It's hard for me to focus there because it was such an issue going on in the background, believe it or not. Okay, there we go. Got that straightened out. So, okay, back to questions on that or comments.
Is John still here? Yeah, he's here.
Yeah, I'm still here.
So, the way Bob described that, an induction motor on the top and a, what was your other one, Bob?
the capacitor start motor.
Was that something that you were talking about earlier, John?
Well, sorry.
No, it's okay.
Basically, yes, that's essentially what I was talking about, and it appears they're both essentially the same. Excuse me, the same wiring. It's just the blue. I can't see it right now because Sandor's got something else up here, but the.
Excuse me, Shandor, is this out of a free thing, or is it some manual that you have to upload, download, or whatever? I don't want any copyright issues on manuals unless they're freely available to the public. Hello? Shandor?
There is no copyright notice on it.
Okay.
Anyway, back to what we were discussing. The if I remember right, the blue one, the top compressor, they removed the capacitor. It's not really required in that because there's no load on it. It's not starting against any sort of.
Can you put the blueprint back up, Rick?
Yeah, there we go. Yeah, because they're essentially both the same. It's just the capacitor was removed from the blue system. It's still at start and run windings. It's going to fire the start windings until it reaches a certain RPM and then kick over to the run side. It doesn't need that capacitor kick because there's no load on that. It's just a compressor to open air. But what you had mentioned before, where you had worked on this, Bob, just with regular AC motors, I believe that's going to work just fine, because I don't think that, Rick sees it a little bit differently than I do, but I don't think that the compressor end of this actually has a whole lot to do with it. I think
this is what I said before. I don't think the compressor so much. That's why I've gone for a straight inductive motor and a capacitive start motor. The reason the capacitor is put into there is to change the power factor of it, and it gives it a much more a stronger torque on the initial start.
Yes.
So if you have a compressor that's under full load, well, that would give you the start for that. But with the other one, you can still run a fridge without the capacitor on it, because you've got the inductive start, standard motor.
That's right.
But with this, once it kicks over and gets into its own right, the relay that will cut out the capacitor, and it also cuts out the second connection through the start winding, which is the S on the. So it then just runs purely through the single coil as part of the infinity loop, with the feedback going through either the red and the black through the capacitors.
Yeah,
Okay.
and the way your coils are firing in opposite phases, that's where you get the concept of the infinity loop.
Correct. Again, the pulse is started by the starter thing, which if you have a push switch on there where you push it down and it goes through the starter with the battery-driven motor, that puts the pulses. Those are AC pulses going from there into the system. That puts the pulses into the circuit there. As soon as the relay trips, it means that the circuit is activated with the magnetic fields within the field coils of those two motors. You take your finger off the start button, the start button, and it then runs autonomously through the feedback.
That's the theory. That's the way it's supposed to work.
Yep.
Whether we can get it to do that is another story.
Well, I'll be trying mine out in the next couple of days. I've been away in Auckland looking after my little granddaughter for the last few days, which is bad timing for me with my project, but good timing for the family.
Okay, I'd like to briefly look at this PTC switch, which I thought it had to do with RPM, but someone in the chat in the live stream mentions it's not a switch, it's a PTC resistor, positive temperature coefficient, and it increases the resistance when the temperature increases. So it's basically a temperature controlled resistor.
Yeah, I'd like to add here, so that's why I brought up that refrigeration and air conditioning motor study guide, that if you hear a click, it means it's a system not with a PTC thermistor, but it is with a relay, with a current relay.
Correct.
So relay makes the click.
Mm-hmm.
In case the resistor is completely silent, just its resistance is increasing as the current and the temperature goes up.
Okay, so what trips the relay though?
So that's what there are different kind of connections on different refrigerators. So we don't have to assume that all are exactly the same, but basically all have a common contact, a start termination for the start coil, and there is a run coil. So C is common, S is start coil, and the R is the run, so that which works on a lower current. When to start it, it needs a bigger current, so it's using an additional coil, which is decoupled, disconnected later, either through a PTC or through a current relay. But the schematics are not the same for all the models, so there may be individual differences. So when you want to replicate this, so you have to understand what was done there in that made in China refrigerator and what's in your refrigerator in the schematics. So what's important here, Mr. Keshe told that when we use these two compressors, one of them has to have a capacitor and the other doesn't have to have a capacitor. Or if both have capacitors for start, then the values shall be different in order to make a gradient. So actually this is a circuit which is producing pulses or an oscillation.
Right. And what kind of oscillation what frequency would that oscillation be? Is that important? How do we tune it? How do we tune our refrigerators? Those are good questions.
Motors are already tuned for the on RPM corresponding to the frequency of the network or something like that.
Right. But do we have to get that resonance between the two refrigerators, like that gradient, that beat? What would that beat be? Is it something, do you is it something that we can tell? Can we measure it somehow? Can we feel it? Can we get it?
We will see the output, but this is the big question. So many people asking, so why it gives exactly 120 or around as the voltage? So probably it was made a startup with such a voltage, and the second, I think this refrigerator compressors have an important role in it.
Would it not be that these motors are synchronous? And so if you're starting it off with a 50 or 60 hertz motor from a 12 volt battery power source, you get your synchronous cycles and frequency there coming through, and then those synchronous motors in the fridge then maintain the synchronicity with your 50 cycle 230 volt or 60 cycle 110 volt.
How would they do with 12 volts at 50 or 60 hertz?
Well, it'll probably give you 12 volts, but again, it'll give you a frequency of your 60 hertz.
So the motors are not, the refrigerators are not for the low voltage. They are for the mains voltage, the grid voltage.
Right, so I'm wondering how do they get to start unless the voltage gets up to, say, 100 volts or whatever it is to get them going?
So that's why you use the start up part, that is on yellow, the starter circuit, which actually gives out the voltage what you need for. So if I may show my camera,
Sure.
I just tear down an aquarium pump. It doesn't work until
there we go.
Gonna start it. Okay, and while the screen share is going on, it's not so easy.
Yeah, it's, just a second here. Let me get you spotlighted.
Okay, this is an aquarium recirculation pump. So it had something like this on one side, and I just teared it down. It has a tiny, maybe 2.5 watts motor. Let's try to wait to focus. Why doesn't it want us the truth? It's on autofocus. Now it goes.
Yeah.
So you see, I'm not in America, I'm in Europe, so we have about 240 volts, 50 hertz. And this is a 2.5 watts motor. And here is its rotor. Actually, you can take it out, and it's only the coil left, which all is made water-proof sealed. And this is the tiny magnet, which is the rotor itself. So now here we have to make a connection to another small motor for a DC motor, low voltage DC motor, which to spin this with a proper speed. And in that case, we will get out of it that starting voltage of how much is our grid. So this is for 220, 240. In your case, in America, you need probably 120 volts and 60 hertz. So just a small device with a small motor, which gives that starting voltage to start up the plasma. Of course, this will not feed not even 500 watts or not 5,000 watts like the other. So this is only 2.5 watts, but this gives the startup signal to start up all. And once you have the plasma created, this is simply removed from the circuit.
Sandos, I've got a different slant on that. Instead of using a motor, if you have a DC voltage going into a motor, is it necessarily going to give you the right rotational revolution rather to give you the 50 cycles at that voltage? Why not just take a 12 volt inverter to, like we have a 230 volts here. I've got a small...
Very good question, a very good question. And now Renan from the PID, from the Product Innovation Development Center, he said that we didn't succeed with electronics.
And, and apparently they were pretty desperate to get the system to work at Washington, and they tried it, a signal generator and an inverter, and it wouldn't work, and they can't just plug in the grid, and they need the pulse of that starter circuit somehow, that it's special with its rotating magnet or whatever it is. I was thinking maybe it's more of a magnetic plasmatic force rather than just a electrical signal down the wire. So
would it not be the fact that the signal generator would only be putting out maybe 1 to 5 volts, whereas an inverter like I was talking about is going to give you the 230 volts at the 50 cycles, and it'll the one I've got is 150 milliamps, which is 150 watts, which is sufficient to give a bit of current to give a kickstart to a motor.
Right, exactly. I think that's. I think that was mentioned that the signal generator didn't have enough power to make to actually power the thing. So, And perhaps we could
now
use.
the question is whether do you want it to be completely off-grid, or you have a grid available and you just want to start your system to become off-grid. Because
Right.
probably if you use a separator transformer which separates you from Earth, just a 1-to-1 ratio power transformer, maybe you can ignite the whole system from your grid. But absolutely, you need that separator transformer to insulate you from the network because you have an Earth here in the schematics.
Yeah, Sandor and Bob, I mentioned earlier you guys weren't in. I worked with a fellow named Gerard Morin in the Lower Mainland a little while ago, and he was working with kind of a plasma system. It wasn't the Keshe plasma; it was a different aspect of it. But his trigger circuit, the circuit he used to trigger his device, was exactly the same as the starter circuit. And we tried AC inverters. We tried driving the motor from a grid power through a power supply. And when we had it attached to the grid, it didn't work. Only when we were running it from a battery did this system actually trigger, and we got the effects that we received. He's got Gerard Morin. If you look him up on YouTube, he's got a bunch of videos on there. The output of this little pump, driven by a DC motor from a battery, has distinctly different properties than if you were to hook up, say, a 12-volt inverter with a pure sine wave inverter. I can't describe exactly what the differences are, but I know it's distinctly different. Even though if you look at it on an oscilloscope, the waveform's probably perfect. It's probably exactly what it is, but there's something else in there. And I believe it's this something else is what we're after to trigger this circuit.
It's well possible because here you create an energy using live magnets.
That's right.
That's right.
And
That's the factor that's different, right? It seems to be the only factor that's different is it's actually a rotating magnet involved rather than in a rotating electrical field or electrical. There's actually a physicality iron rotating rather than just copper.
That's a good point because we say there's an electric current and you have no clue about what the electric current is.
And the fact that
you would ask James Clerk Feynman, listen to his, such kind of questions. There are so many reports with him.
Actually, can I come in here?
That's Mario, right? Hi, Mario.
Yeah. Hello, everybody. I had been studying before I learned about Mr. Keshe, trying to understand the physics of electrons flow and electricity, and I found nothing until I ran into Eric Dollard's videos that led me to reading Oliver Heaviside's book and the compendium, which is the history of the development of the physics of electrons and electricity. And what I learned before I knew anything about Mr. Keshe's, Oliver Heaviside in the 1880s and 90s discovered that there was no such thing as electrons. It was the magnetic fields. Tesla.
Sorry. The great question is: are the electrons flowing at all?
No, no electrons flowing at all. And
but that idea is taught by the schools because they have to explain something which they don't understand. They have to give a fixed
the Steinmetz equations that mathematicians use is a way of converting the fields from the magnetic field information into a formula for electrons. The Coulomb's calculations, all that stuff, it's all bullshit. It's all bullshit. Magnetic fields are what electricity really is. And that's why magnets are making a difference. What Tesla did with everything we have now is basically based on Tesla's designs from the 1890s. We have upgraded versions of 1890s technology. It's Tesla. And what I believe Tesla was doing was teaching a behavior to the magnetic fields. He did not know about the gravitational fields, but he had total manipulation of the magnetic fields, but he taught a specific behavior. The problem is, for us now, is he used the resistance and of the copper, and he used the limitations of the iron magnets to teach that behavior to the magnetic fields. And if you're going to use plasma, you cannot replicate that exact behavior. You have to figure out a different way than Tesla did to create that 50 hertz cycle. And I think what's happening here is you've got two sets of magnets rotating. Those are generators. They're a regular, but they're tuned already to 50 hertz. And you need a pull from one to the other so that you create an infinity loop. What you're really doing is creating a central core in the center that once that kicks in, once you open up a central core, that's tuned like any other note. Everything in the universe got its own pitch. That's tuned to 50 hertz. And then once that kicks in, now you have a generator. Now you have the Magrav units are tuned to Tesla's behavior. It's as simple as that. I don't know how to help you guys. Resistors and capacitors and stuff, I have no idea really what you're even talking about. I still haven't figured out how to use a voltmeter. So I don't know anything about that. But I know that Tesla trained the plasma of iron magnets. Iron magnets are magnets. Ganses are magnets. You generate a dynamic plasma field by rotating magnets. These are rotating magnets. Ganses are rotating magnets. Even the coils, because you've got a routing of magnetical and gravitational fields, but you also have a composite Gans, which creates a gradient. So those are rotating fields by themselves. The thing is, how do you use them to plug in your appliances that are tuned to the behavior of Tesla? Yeah, first you plug them into the grid. That's giving it the behavior, and you're training the Magravs the same way as you're training CO2 when you put a banana on top. Doing exactly the same thing. I don't know.
Mario, a couple of things maybe you might be missing there. With the motor in the yellow box, starting off from there, the frequency is determined by the number of turns or rotations per second, per minute, or whatever. The same with Tesla. He rated the number of turns, gave you the frequency, and he selected as for whatever his own purpose was, either the 50 or the 60. I think the difference between 50 and 60 was a copyright or a patent thing between countries. If you look at the starter motor, if you're saying that you have a motor because it's magnetic, with a motor, you've also got the difference of lead and lag between the capacitance and the resistance and reactance of the output of current and voltage. That will give you a slight difference. If you have a sinusoidal wave from say an inverter or something like that, you don't get that lead lag or the reactance difference in the resistances and the current and the voltage going through the system. It may be, as you said before, that this thing that was missing with an inverter is the fact that it didn't have the lag of the current from the voltage going through to set the relationship between the inductive and the capacitive motors. Just to throw that in for a bit of thought.
Okay, I really didn't understand most of that. I'm just looking at it as a plasma field that's got a particular behavior. It's exactly like talking on a telephone. That's what Oliver Heaviside was working on, long distance telephone. What he discovered is you vibrating a magnet on one end and it vibrates the magnet on the other end. And that was the telegraph, was just pushing the magnet, it pushed the magnet on the other end. The telephone was putting a wafer thin piece of metal that vibrated and stored the memory in the field. And it remembered it and it transmitted the field and it remembered that vibrational pattern. That's memory. That's exactly what's happening with the banana. When you create a flow and you got a banana on top, the fields go through the banana, they store the banana's fields in the water. And that gets into the Gans. And it stores it. It's a memory. Your computer is a magnetic memory chip that stores everything on the magnetic fields. Now, I'm not sure how to help you directly to solve this problem, but I think if you need to have a translation of understanding electrons and what you call resistance. Like Oliver Heaviside called copper wire reflectors. The magnetic fields will not pass through the copper wire. So they bounce off. And it's the copper wires not superconductive. So they what they do, they create drag. They create drag and scrape fields.
That's
and
why
so,
Mr. Keshe wanted to go with the hollow copper wire to melt out the inside and just have it nano-coated inside it out. Just a thin nano-coating was enough to transfer the plasma.
Of the fields of the copper, even though your conduct is still enough to create drag. That's what causes the heat and light, if you get sparks, is from the friction of the magnetic field spiraling around the outside of the wire. That's what's going on with all electricity. It's the problem is Tesla used those problems that, like for us, copper wire you can't use for plasma. Why? Because you need to have superconductivity. So how Tesla used the non-superconductivity of the copper to teach a behavior, to create a vibrational pattern. How do you replicate that behavior? Like, how do you get banana without banana? You know, it's sort of a problem. You've got to figure out a way to replicate that exact behavior using superconductive materials. Once you've got the behavior, no problem. Well, I think this kicks it in and it opens up the central core that's tuned to the frequency of, because those devices are set to run from Tesla's behavior. So if you use those, you're training that, you're teaching a behavior to a central core. Okay, I guess I said enough. I don't know if that's helped for any, or if it just waste of time. Sorry if it's a waste of time.
No, Mario, I don't consider your comments a waste of time at all. I mean, you listened to the other technical explanation and so on, and it didn't make any sense to you. It made sense to me, but then your explanation also makes sense to me from a different perspective and an insightful point of view, but without that electrical, technical part that's insignificant to you, because you're looking at the principles, the main plasmatic principles involved here. And that I always appreciate your point of view that way, and I'm sure many people do. And you brought up, I wanted to point out, literally point out, not me, but this is Douglas pointing out about what you just mentioned about the matter level copper that gets involved, and how it, in this case, it actually interferes with the circuit. So let's just listen to him. Oh, I have to select the audio here, maybe, so that I can share it that way. Just a second. I think that might work if I'm really lucky this time around. Let me know if the audio doesn't work here. It should. It'll just be a minute or so of, or less than a minute of, where he explains, I'll just set this up. He explains this, I don't know if you can see my pointer, but it's right by his hand, by his index finger there. There's a burnt spot in the board, and that's where the missing capacitor would have been, but he's bypassed it with a piece of copper wire, and he explains what happened. Let's see if I got it right here.
And wattage through nano-coated wires, and through the nano-coating process allows this to become a superconductor, which allows the electricity to travel through here at a higher rate of speed, frequency if you will, so less resistance. If there's no resistance, there's no heat. This is a new piece of wire right here, and it's warm to the touch, but it's not hot anymore. But that's the reason it became hot, because it was a brand new piece of wire. It hasn't been nano coated yet. So this was put in here on purpose to show you You see that none of the rest of that left a mark there, you know, just the one spot right there. I had my knee on that ground, and like I said, the two systems are making electricity right now, so it will give you a little bit of a shock there if you touch the ground on one side. But anyway.
So anyway, there you were talking, Mary, about the superconducting and the regular copper. Well, that's what happened in this system, and that's a big clue to us in terms of if we were put up back up the main schematic here of the. Let me do a new share and just get that back up again. In terms of the way the circuit works, it's a plasma. We have to remember that it is a plasmatic circuit and not necessarily an electron flow circuit. Because the way I understand it, generally speaking, the plasmatic circuit is, well, basically exactly opposite flow direction of the electron circuit, or what we consider to be the flow normally in electrical terms. So I think if we sort of look at things backwards in a way, then we'll get more clues on how it works than trying to force the issue electrically the way it should be. Sorry, go ahead. Someone had a...
Can I just ask a question?
Mm-hmm.
Like, the fellow from New Zealand who was just talking, I didn't get your name. Well, you sound like you have a lot of expertise in this as electrical circuits. A lot of you do. Rick, you definitely do. Can anybody explain this strictly as a flow? For every electron current, according to traditional Faraday law, there's a magnetic field spiraling around in the direction of the flow of the electrons, directly perpendicular. It's a 90-degree angle, but it's a spiraling around. Can anybody like follow the magnetic field from this circuit from the beginning to the end? Like, what are the magnetic fields? Forget about the electrons, because Tesla only used the magnetic fields. So for anything that's electrical, you're manipulating the magnetic fields. If you can find where the magnetic fields flow from one part, from the beginning to the end, then maybe somebody with electronic skills and knowledge that I don't have at all, but a lot of you do, can redefine those words. You know, resistance here is a manipulation of the magnetic field going in this direction, or doing that, or doing this. Like, convert this from electron circuit to a magnetic field circuit.
The answer is yes or no. The difficulty is that you've got an alternating current circuit, and so the magnetic fields are changing every cycle, changing twice. So once to the positive, once to the negative. So you can only say that at a point in time, when the cycle is at the zero start, the magnetic fields will be one way, and then it gets up to the 90 degrees, which is the top of the cycle, the magnetic fields will be another way, and that will go through the 4 different phases of the cycle. So from that point of view, you can only do it in fragments of the cycle, but not the complete cycle.
And there's another point. Wait a minute, Mario. There's another point of view too, because that's the ordinary, not ordinary, but someone that's experienced electrician, or even electronics point of view. But if you look at it from a nano point of view, then, for example, the plasma capacitors and the coils, especially the coils are coated with Gans and the setup and so on, we have to look at the nanomagnetics going on rather than just the electrical wire magnetics. And then you have to look at there's various scales of that. There's the atomic level. There are all the atoms spinning in the same direction, or now are they all normally they're all mixed up. Are they now all spinning in the same direction on the atomic level? You look at the nano level, are the nanoparticles allowing the plasma to flow in one direction but not the other? And that creates a certain form of field compared to just a wire where you have a flow of electrons and it has a specific magnetic field around it. But if the wire is nano-coated with 30,000 layers of nano-coating, that creates a whole different field effect and a different flow pattern for the plasma, which allows it to flow backwards to the flow of the electrons, because electrons and plasma sort of, the way I understand it, basically interfere with each other. You don't want... we're not looking for electron flow, although ultimately something happens with electrons, I guess, but it's not the electron flow that we're looking for. Therefore, like for example, the magnetic field around any of these wires that are hookup wires, from a copper point of view, you would have, where's my annotate? Where do I have an annotate?
I just thought Mario's question was based on conventional electrical or electronics theory. I thought he was coming from it from that angle initially.
No. I was looking at, if you take what you just said.
Tony from Australia. Yeah.
If you take what you just said about the magnet, about the alternating current, if you look at the behavior of the magnetic field, you'll find that that's what Tesla used to restrict the expansion of that magnetic field, as it tends to want to expand around the outside of the wire. He used that for long distance transmission of the fields. And so what he's really doing is you have a magnetic field that's pushing, and then a magnetic field that's pulling, and then pushing, and then pulling, and regulating the coiling effect of the magnetic field. That's all it is. That's all it is. That's all AC is doing, is regulating the thickness, like literally like determining how thick your coil is going to be. He's literally doing that with the fields themselves.
There is another couple of things here with Tesla. With a capacitance, if you just stick a DC voltage across a capacitor, it sits there and looks at you. Go back to the fundamentals, that the only time that you can get a change of current reflected across a capacitor is you've got to have the rising voltage going to one polarity and then down to the other polarity. And when there's a positive on one plate or one side, there will be a negative on the other, and that's the charge between the two plates. If you follow the circle around with the Magrav coils there, the only way that you can get induction between the coils is by having a varying voltage between a positive and a negative from one side to the other side of the coils. I don't know about gravitational fields because I don't understand them fully myself yet, but I can only assume that a gravitational field will work the same as a magnetic field, where you've got to have a changing of polarity to get that induction across between the different coils that will then reflect into the feedback.
I don't think that's correct. I don't think that's correct. I'm sorry. I mean, I don't think there is any induction. There's no such thing as induction. It's nothing but a magnetic and a gravitational plasma field. The thing is, Tesla didn't know about the gravitational, so he only used one coil. He doesn't have a coil inside the coil, so he doesn't have any control over the gravitational fields. If he did, we'd have been flying in space 100 years ago. Tesla would have uncovered what we now know that Mr. Keshe has given us. He only knew how to manipulate the magnetic fields, but they are magnetic and gravitational fields. There's no induction. Every bit of this circuit is a flow of plasma. You all always treat electricity and electron vibration as if it's a different phenomenon than plasma. It's not.
No. Tesla did use induction. He had the coils. The way that he worked to change the polarity within his main coils was he used the spark gap. The spark gave you zero voltage or A voltage, and that induced a change within the magnetic field of the first coil. The secondary coil the first coil was always a large coil of many turns, and then the secondary coil was just a couple of turns, and he would induce a a large voltage through the primary one, and that would in turn induce a huge voltage into the secondary. And that's how he got his huge sparks. But the magnetic field was changed by the spark gap.
But you're presuming that there's a flow of electrons. If there's no such thing as a flow of electrons, then it's nothing but the magnetic field spiraling around the wire.
That's what I am assuming. It is a magnetic field, there's nothing else. It's just the magnetic induction between two windings.
It's a magnetical and gravitational fields spiraling around those coils.
In this case, yes.
Electricity is magnetic gravitational plasma fields, all of them. Every device in your house is a plasma device. It's just run on the field strength of iron magnets. The only difference between electricity, you don't have electricity without magnets. How do you generate all electricity, DC or AC? Rotate the magnets. But AC is a lot more complicated version of rotating magnets from Tesla. DC was Edison. A paddle wheel rotating gives you DC. That's because that's one behavior. It's just the basic behavior of plasma. That's why everything in the universe is DC. There's no such thing as electrons. They don't exist. That's a quote from Mr. Keshe. In plasma physics, there is no electrons. There's only magnetic gravitational plasmas. That's why all of you trying to figure out, you should be trying to figure out, is how do you convert a 19th century understanding of physics of electrons into a magnetic gravitational plasma understanding of interaction of fields. I don't have those kind of skills of what you guys have, but if you all have the same understanding of plasma as I do, if you change your understanding of what it is you're looking at here, if you treat and then take the information you have is all correct, it's just that you're looking at it as a different kind of physics. There's not two different physics of the universe.
Isn't that what we're doing now? In that there are people from all kinds of different backgrounds. There are people with electronics backgrounds. You know, I've got a background like that. This guy obviously does. And then there are people who see things purely from a plasma state. Just by sharing, you know, we're kind of mixing and bouncing ideas off each other in that direction, you know, to get a better understanding.
Yeah, that's the beauty of a group like this. It's totally multidiscipline. We're not all specific in one. We're not all electronic technicians, for example. But some of us have dabbled in electronics. Some of us may be electronic technicians. Others of us are poets and painters. And this is the thing. When you bring it all together, sometimes there's friction because we're trying to understand each's point of view. But the thing about it is, we're all here because there's something in our heart that brought us here. And that essence being that seems to keep coming up in this particular teaching does have a common viewpoint. It is able to understand the universe in the way that we all do, because we all are one being essentially. But we do have the various experiences and viewpoints, and if we can accept all these viewpoints, it can add to our own viewpoint to become more understanding of what this one being actually is capable of perceiving from all these different, as Mr. Keshe says, windows. He said recently that he has the ability to look at situations from many windows, from different angles, that he specifically sets up as a perspective or a viewpoint. And if we can incorporate these, and I mean, even this drawing that we're looking at here is doing that. It's trying to incorporate both the plasma and ordinary stuff that we were used to, like wires and compressors and things. Like they just stick these, coils on the bottom and show the connection like it's all normal. But to us that are used to this now, it's, you have these Gans balls, you've got Gans coated coils. There's this whole process and technology that's involved with them that has nothing to do with electrons, basically. That's all to do with plasma.
Definitely. And I think we're all being played. You know, it's like with this little beautiful piece of work's being thrown in front of us, and we're going to debate this and figure it and roll it around and, poke bits at it. and we're going to get quite comfortable with this. And in a few weeks' time or a few days' time, he's going to, you know, throw, you know, he only gives us what we can take at a time, you know.
Yeah.
And we're chewing on this, and I love it. He's going to throw something else into the works. He's going to lift us another 15 feet above where we are now, and we're going to have a different perspective, and it's all going to change.
Yeah, the thing is, we have the capability of lifting ourselves up too, because many people have clues about this. For example, let's bring in Pontus Hasber, who I don't know, but he's got his hand up and he tried to talk a couple of times earlier. So let's, I think he might have something to add here. Just a hunch. Hello?
Yes, hello. This is Pontus from Sweden.
And
I have been looking at...
sorry, Pontus, where are you from?
Sweden.
Okay, Sweden. Thank you.
I have been looking at the QEG, Nikola Tesla's QEG, Quantum Energy Generator. And it has something that's similar to the hybrid generator, Magrav. So I think we should look at that to get a good idea of how it's working.
That's similar to the starter circuit. So a DC motor is spinning a generator, and nothing more common in it.
No, I know, but it is what's it called?
Have you seen any QEG generator which produces some more output than the input?
Yes, I think
because I knew the WITS machine, which was said it's working, but nobody has seen it, and its author was selling the plans for $300 a set for the plans for the blueprints. And later it was this other group which is now in Morocco, who changed the name to QEG, and they give the plans for free, but they charge $300 per hour for consultancy via Skype in case if it doesn't work. It's a nice business because many people will ask for how to make it working.
Yeah, but I think there is something in the plans that we could maybe use.
Look, I'm Sándor, I'm here in Hungary. So we in Hungary, you have, I know about at least 5 people who since years, they put a lot of effort to build such a QEG according to the plans. One of them made a whole workshop making tooling for making cores for the generators, for making coiling machines and so on. And finally, he realized to produce a generator which had a great efficiency of about 65%. So much less than commercial generators.
Okay.
That's why I'm asking, have you ever seen a working unit of it?
No, I haven't seen it. I just referred to YouTube, and I don't know if it's real.
Yeah, I looked into it a little bit as well when it first came out, and tried to figure out why were they using the name Tesla referring to this, because Tesla never had, first of all, a quantum energy generator, and he didn't even have an energy generator that was based on that kind of circuitry. So it seemed kind of misleading to start with, and I never seen a working unit yet from that group. So I don't know, but some of the principles may be similar. Maybe they are working with that kind of energy.
If I may add here, so Tesla had a patent for rotating machine, which is a generator, you know, like a dynamo or an alternator, a generator. You spin its axis and it produces electric output. And the invention of Tesla was an addition to the previous ones, that if you make the coils to be tuned to electrically or electromagnetically to the frequency of rotation of the rotor, in that case, it will have a better efficiency. That was all. It was not saying that the efficiency will be more than 100%.
Right.
But some
And
people
that's-
exploited people's ideas about this mystified Tesla thing, that hidden or forbidden patents, which were not hidden, not forbidden. They were available. They are in public domain since so many years.
Mm-hmm. He did have a pulsating device that worked with electrical power, and there were rumors that it might be able to run with over Unity, as there were rumors that his Tesla turbine also could run with over Unity, meaning it could actually run without the input energy from fuel going into it once at a certain speed. But those were rumors, and that was not part of his patents, not part of anything that's available to anyone, that, at least in the known universe, other than some underground vault somewhere where maybe something secret from Tesla may lie. But I don't think that that's the case with the QEG, but I don't know. So any other input or opinion on that? If someone...
There's something about frequencies I'd like to say.
Mm-hmm.
You know, John had said something about frequencies of fields. For him, he is a musician. I'm the same way. It's easier for us to understand. Armin stepped in and said, it's not frequencies, it's field strengths. So again, I always, every time you talk about Tesla, everything he dealt with was frequencies. The frequencies of the spiraling of the magnetic field, which is what we call AC. The 50 hertz is a frequency.
Yeah, but wait a minute. Before you go on in that, with Tesla, it was not frequency, though. To him, he never used the word frequency. He was talking about rate, which was actually the inverse. Is the inverse of frequency, and it was more like pulse rather than frequency.
Well, yeah, just like AC current, reversing the magnet's polarity. So push, pull, push, pull, push, pull, push, pull. He can control the fields. It's creating, if you want to call it a frequency, it's not the right word. It's field strength. 50 hertz is a particular field strength. How do you get that? A banana is a certain field strength. Not frequency, field strength. What Armin was correcting, I mean, I think John understood it at the time. I understand it that way.
Keshe has always said it that way as well. You're right. He said there's no such thing as frequency, and he talks about pulse sometimes, and he talks about field strength. That's right.
Right. Well, so 50 hertz is not electron anything. It's a particular field strength generated from a plasma generator. That's all it really is. And if some people who understood about electronics, I'll say this again, I think I said it, could reevaluate those kinds of terms and put them into an understanding of a manipulation of a plasma field, then people like me could read the schematic, and maybe I could actually help you guys figure out how to make it work. But as of now,
all right.
See, that's kind of what I'm asking.
So it's almost like we need a new kind of schematic when it comes right down to it. And when you look at the picture we have on the screen here now, it is a new kind of schematic. In fact, you mentioned earlier how nice the picture was, what a nice layout it is, and what a good artist this was, and it's so clear, and it's the color arrangements, it's the way things are laid out, and the legend. Normally in electrical things, you don't have you have color coding and so on to keep the wires all apart and so on, but it's in a different way, and I think we have to keep advancing to use some kind of plasmatic icons, you might say, for different parts of our plasma circuits, and maybe we can have electronics and electrician technicians and whizzes help us to envision these little modules, plasma modules that could plug in.
By the way, Rick, if you switch to my camera instead of the shared screen, you will see I'm just drawing schematics where I changed a bit the position to be more easy to see it. And the starter circuit, I didn't represent it, just here it comes the starter circuit with the battery and the spinning motor and generator. So here is the output.
Okay, sorry, Chandra, could you say that again, please?
And here is an earth. Somewhere I can draw here is an earth, okay? So this is its full schematics, and here these are the magnetical, gravitational. So I didn't draw now exactly all the lines of that. Just maybe it makes more clear about what happens, and I added the coils which are within the compressor. I understood from the configuration of that refrigerator unit of 1.7 cubic feet, which in European terms would be 48 liters, small size, such a bedroom or hotel refrigerator. So that is mentioned a PTC, but if it makes a click, it shouldn't be a PTC. And if it would be a PTC, it would be connected in another way. So this is a current relay probably, which has a switch here. Otherwise, if it would be PTC, that would be in parallel, not in series with the capacitor. So that's why I opened that study manual about all the configuration of the refrigerator and air conditioning motors. So here you can follow up all the circuitry, how it goes. So when it starts, it gets an input here. And what you see, this is making a round circuit together with other consumers, or this is coils. Maybe I put my annotation tool and to let it. Sorry, I have no stand. I have no tripod here to make it more clear. So this is the best camera position.
We can see quite well, Chandra, not a problem there.
Yeah, I have no annotation tool now. So anyway, let's take a. Not necessary. I can draw it again. But if you would allow me to record, in that case later I could see it. But anyway, you will have a record positive movie, so don't worry. So let's follow the startup. In case of it gets a startup, oh, I bought a brand new pen, and it's overfilled, so it's dripping green ink. So this is a bad surprise. Factory filled too much ink into it. I just opened a new one. Yeah, to change, to choose another color. So for the startup, this is connected here. So it comes the circuit from here. It goes here. It goes through these Magrav units, and then it goes through the secondary compressor, like this, comes like this, and so on. And also it goes, no, it doesn't go through any other. So in case of start, it starts for the compressor, not the refrigerator. So this is the refrigerator, this is the compressor. Once it goes there, the Magrav unit starts to make some plasma.
Are you missing? It shouldn't go out right there. It should go loop around the other compressor first. Shouldn't it go through the compressor?
So that's the interesting thing here. That's the interesting thing here. So because actually it would go through this capacitor. You see, this is the C, the capacitor, and it goes not here because yes, it goes. Sorry, yes, and it goes through here too. Yes, it closes two loops. So there is a. This is one loop, and this is the bigger loop, and this is the other loop. Yes, right. So from here to here, it closes that also. And this is this was I didn't erase that switch. So on start it's in this position. So here it gets feeding to the capacitors, to the compressors. So this is in the case of startup.
How does it connect to both those compressors? Which direction?
So this is how they are connected. You see, this is the C, it's the common, and the start coil and the run coil. Start coil and run coil. And when it starts spinning at enough high speed, in that case, this switch operates and it shorts this, it overcomes. So after the start, it will go only through the run coil and not through the start coil. So this is the start coil, this is the run coil.
So then it goes in one direction and goes around and creates a figure 8 around both compressors.
Where you see the figure 8?
Well, you just said you have the C and the S, and you have the C and the S where they're going the other direction.
Oh, please check how we connected. It depends how you put it there, how you draw it. So if on paper it's a figure 8, and you see on the desk one is here, the other is here, you don't find the figure 8.
Well, if you look at it, just a minute, Mario, if you look at one compressor is hooked up with the positive going and negative in one direction. The other one is with the negative going to the positive of the other one and to the negative. So they're both hooked up. One's hooked up backwards compared to normal, let's say.
Right. Exactly.
So this is the common point. This is the common point. Yes, and
right. So if that's a common ground,
this
then,
is and that's why they are in opposite phase, in opposite direction. So
right.
in AC, it's no sense for the direction, but we see for the same positive pulse, it would be one would have this direction, and the other will have this direction.
Right. So okay, follow through your arrows there and go along that wire, and then come back with your. Just follow through with your arrow, just the way you did there, and follow along the wire. Yes. And then over to no. Yeah, just the figure 8 between the two units there. Just you've got the arrows already. You've got one. Just do like the figure 8.
What's interesting? These two are connected together. You see, this is a common place, and this is a common place here.
But go from the top of the right circle where the arrow is, and just draw it straight through. Continue the line past where you put the arrow. Right. Go go straight down.
Down.
Why to go down?
Not down, but over to the other circle. Over to the bottom of the other circle. From the top of the right circle. The top of the right circle where your arrow is, there. Now continue to the other circle on the left, to the bottom part of the left circle. The bottom part of the left circle. Bottom, yeah, there. No,
this is not at the start, it is after it started.
No, don't follow the wire, Sandor. Don't follow the wire.
This is exactly the confusion we're running into here. It's interesting. I'm trying to follow. I'm looking at the arrow, and we're talking about the flow here. So you got the arrows going like that. So I'm trying to get you to make a figure 8. Just make a figure 8 between the two circles, following your arrows. Basically, is what we're trying to get you to do there, and that forms a plasmatic interchange or drawing rather than the flow of power as we know it, the flow of charge or electrons or whatever you like to do, which always goes along the wires. We're starting to try to come up with a new type of drawing.
What we want to see, the circuit at the start or the circuit when it's running already?
Right. But what's going to happen is that right circle, the fields coming out of the top of that are going to go around and go into the fields of the...
what is the right circle? The compressor, let's name. This is the fridge.
Yeah, and then the other circle...
This is the compressor.
Okay,
the central compressor.
So the fields are coming out of the top of the refrigerator, the fridge, going into the bottom of the
So this is entry. This is
No,
exit. This is a common. This is not common. It's not top, not bottom.
Not the wiring, not the circuitry, the fields.
So normally it's the motors are in a closed metal case, in a steel case here, like a bomb, which has a pump.
Yeah, but they're invisible.
And it has here a capacitor somewhere, and all the electric is inside. So I don't know what fields are coming out from the Faraday cage.
Well, you can see right here what Mr. Keshe is saying. Just draw a line from the top of the right circle and connect it to the bottom of the left circle.
How about if I take a screenshot?
Sure. I already did.
Instead of the camera, you can
Yeah.
go with the application.
Yeah, that's a good idea. Do that, Chandra. In fact, I've already done
I
it.
clean it out for my annotations.
I've already done it here, Shandor. So let's set that up here, and there, you should be able to see that.
Yes, great. Thank you.
Now, I think if we can get the annotate tool, here we go. Let me try to demonstrate. I think this is what Mario is talking about. Okay. You got your arrow here that you've shown. How come it's so skinny? It should be fat. Okay, and so he was talking about continuing this over to here, and then you go up, connect with your other arrow, and back down and around. That's the infinity loop. Isn't that what you're talking about, Mario?
Yes, that's exactly it. And that's why in the very center of that, if those fields, those are magnetic fields outside of the wiring, and if those intersect at the center, we'll open up the center core, and it'll be tuned to the fields that are generating it. So now you get your 50 hertz. And it creates a feedback loop on itself because the fields are going in and out of the center. And it doesn't have to be physically connected in a figure way. They can be, as long as they're close enough to interact, you will get your central core tuned. So that's a way to replicate Tesla's behavior pattern using this.
Yeah, now it's very interesting. Just one thing, what's the status of this PTC solid state switch and of the startup relay? Because we consider that it's closed, it's a closed circuit, it's connected.
Well, once the unit clicks, that means doesn't that shut off? That should close off the circuit. So then you can unplug the starters. You don't need anything.
So when it clicks, it means that on the right side at the fridge that relay is closed. Gets closed. That one gets closed. So the run coil will get all the power, and the start with the capacitor will not come so much into the play. And on the other side, it means that the PTC disconnects when it starts going. And this is why I'm wondering why it was drawn in this way, because it's just the opposite way. Normally, it should be up like that.
Well, that way, so now you create your infinity loop. You've got one going, and then once that triggers, it clicks off, now you've got both of them operating, and you've got your infinity loop. And then what you're really doing is getting the fields not from either of those refrigerator or compressor. You're actually getting it from a central core, and it's drawing from the your three Magrav coils.
And we're told that there's a giver and a receiver in these in this infinity coil relationship as well. So one is different than the other in terms of its circuitry, and that's partly why that loop works. It gives it a gradient that works.
And now the question, is it need for compressors or just it's need for those coils and loops?
Well, this is the thing. In our plasmatic diagram, which we have here, which only has the infinity loop, you can put anything in there that will substitute for that infinity loop, I figure. And that's the beauty of having a plasmatic schematic, hey, that works good, plasmatic schematic, rather than an electrical schematic, because the electrical can fool us, whereas the plasmatic always comes before the matter level. So if we can, this is something new. I think that if we can learn to develop plasmatic schematics, then we can both the electronics and electricians can approach it, and the poets and the artists can also approach it. So I mean, that's the question: can we use this compressor, that compressor? Can we use this circuit, that circuit? Anything that would give you that infinity loop will do, with a giving and receiving, you know, which is natural to this circuit anyway, and we just substitute
by the
it
way,
in.
how about this part of the circuitry here, which includes this capacitor?
Well, yeah. Can
Right.
I come back for a second? Let me just say something.
Can I just ask, the whole purpose of this part of the circuit is to create a pulse?
That's what I believe is part of the what we call the resonance or pulse. Because if you look at, for example, if this was vibrating at 1,000 and this is vibrating at 1,200, the difference between them might be 200, which means that would be the pulse. That would be the beat frequency. It's often called beat frequency. You guys, musicians, know about that. You will hear two notes that are really close together, and all of a sudden you hear wah 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 wah. That's the beat frequency. That's in between. It's the difference between the two notes. So maybe it's the difference is what we're looking for.
That's why if I could just incite this one thing, you can use anything to create the infinity loop, but you need to be able to plug in your electronic devices that are tuned to Tesla's particular pitch. So that's why you have to use a compressor or a refrigerator or something that's already got a mechanism in it that will generate that particular pitch. It's the banana.
Synchronous motors, yes, it's the synchronous motor here.
That's right. It's the banana on your Magrav coils. It's basically something to teach that particular pulse. That particular
depending on the particular culture and time period of the universe we happen to be in, because different ones may use different pulses or different types of devices that may be...
Our big issue in our culture is that we use 50, 60 hertz frequency. Well, we shouldn't.
That's Tesla. That was Tesla's design. That's what he came up with.
Yes, and it was very good about transmission of power through the wires because of the possibility of using transformers. And when they transport it on high voltage lines, it's a small current, and all the losses are due to the current, not due to the voltage, because current produces the heating of the wires and the energy loss. And at the point of consumption, you have no 10,000 or 30,000 or 100,000 volts, but you have a low voltage. But finally, you see, we are using computers, we are using TVs, and they all work with DC. And we have DC motors for the spinning application. So it's now we are in a situation that we are obliged just for compatibility to use this 120 volts 60 hertz or 230 volts 50 hertz.
Right.
Which finally we have adapters on our desks and in our plugs just to convert it to what we really need. So now the next question would be, because we need this pulse at a certain frequency just because of our appliances are working with AC. Now, if we have this pulse generator in the middle, that infinity loop thing, which physical power does it have to have?
None, plasma only.
So it can be reduced in size very much. You don't need a huge compressor, which is, I don't know, 5 kilograms, full of iron and copper. So we can design a smaller device which to do the same thing.
Can I ask, what problem was Douglas not able to get a new pulse started again? Is it still a problem, or I thought that has been solved already? Can Douglas's device be powered up all the time, or was
yes,
he having...
of course. Yes, of course. Now it was an organizing about where to make a press conference. So now on Facebook it was already published exactly on some chat groups. So today at 6 p.m. Eastern time, there will be a press conference in Washington in the, let me see exactly the text. Just a second.
So just let me just ask then.
It's
so in other words,
in the National Press Club McLendon Room on 14th Street Northwest, number 529, on the 13th floors in Washington, D.C.
That's fantastic.
Well,
Yeah, I think Carolina released this last night.
we can't see it, Rick. We can't see it, Rick. No,
We see your desktop.
We got a whole bunch of folders. There you go. Well, I got to interrupt here again. Shandor was on a roll, and he was he'd gotten down. Well, we don't need these large compressors. We can. What we're after is to we can go a lot smaller. Shandor, what would have been your suggestion? What would you do? What would you use?
So I would do by the trial and error to find what fits, what makes it working. But first of all, I try to redraw this. I try to redraw this circuit in a way to be more easy to see, so to be not so many crossing wires, which makes it more difficult to read it. So I worked a lot in electronics, in schematics, and sometimes if you arrange it's not twisted, it's easier to see where are the loops. And still, this is not the best. So I will refine it to make it more easy. But at least we can see what happens there. So what are the actual components inside those refrigerators? So I'm wondering whether is it need for the start coil and the run coil, or a simpler version would be enough?
Sandor, can I throw another penny in there? The 12 again. With the schematic that you've done there, it's very, very good. I think it's really good. With the compressor and the refrigerator, I'm just replacing it with just the motors out of a refrigerator or a compressor. only without having the whole 9 yards there. But I do believe that we could substitute the field coils within the motor with these little toroid coils. If you look at the power supply of a computer or any of those, they use the toroids, and they use them for 12 volts, they use them for 230 volts. And so if you had a toroid on the start coil and a toroid on your run coil, and then a PTC or a relay on your start mechanism. So you use the same mechanism for starting with a PTC or a relay, that once it starts to click, you just cut the starter off, and that would give you a substitute, and you'd be able to miniaturize it.
Yeah, possibly. But just I'm wondering how important it is to have a motor which has a spinning magnet, a rotor which has magnets inside.
What you're looking at is
the motor, so it has no brushes, no coils on the rotor. I think it's a magnet or something like that, but we can look at the technical.
I think you're right on that. What you're looking at with a toroid, instead of having the motor with brushes and all that sort of stuff, is you have the toroid there with the signal or the pulse going through it, and it's the rise and fall or the decay of that pulse which gives you the generation of your infinity loop.
I think when the rotor spins, because it's synchronous, maybe that fields of the magnetic fields of the rotor also make some interaction while it's spinning.
Now, with the rise and decay of those voltages, when you're pulsing with your start, that would give you the simulation of a rotary armature spinning.
I understood that this is not just for the start impulse it's needed, but also for keeping it running.
Yeah, but you not only do you have...
Look here, if after we started, we connect this here, A to C instead of B, and here we will have a closed loop here. So this makes it very funny. Okay, so maybe I have to mark with a different color. Maybe I have to mark with a different color. So let's make this the so-called fake live. Okay.
But yeah, where you have your on your fridge, the RTC PTC there, or your relay, that would be normally closed. Sorry, normally closed for start, and then once it's running, it goes normally open, right?
It opens. Oh, okay. So just in that case, if it's open, then the run will not get. I'm wondering, isn't any mistake on that schematics? Isn't reverse the R and S?
I think the capacitor's on the run side, not the start side.
Yeah. So you know that this blueprint schematics were done very quickly.
Yeah, I think
it's possible to have such a small typo in. So maybe I suppose that this would be the start and this would be the run, and this would be logical. This would be the run and the start, and that puts it all in its place. Because in that case, the start relay, it's a current relay. So when you get I'm not sure about that, but anyway.
You only need the start coil in when you're doing the trigger.
The start coil is needed just for the compressor to be able to spin up, and it's not important for the Magrav viewpoint, I think.
Correct.
So maybe we can eliminate all the other coils and just to leave the run coils, supposing that you have a motor which doesn't need that.
Okay, and this is where I say where you have the difference between the two. If you have a couple of these toroidal chokes in there, with the rise of one and the decay of the other, that will give you a time frame, and it may need the capacitance there to give you or maintain your frequency of the 50 cycle or 60 cycles, because there will be there'll be inductive reactance and reactance between the two, and then that will give you the frequency for your infinity loop. That would give you the determination of the size of the choke that you need with that toroidal coil.
Mm-hmm. Yeah. Meanwhile, Rick, I sent you the link where from this refrigeration and air conditioning motor types manual was posted. It's mentioned the Creative Commons.
It seems like it'd be fine to show it. We just have to do an honorable mention that where it came from or whatever, and it should be fine, right?
Yeah, so let's look in the chat where I wrote exactly the source. So this comes from HVAC education.wikispaces.com.
Okay.
And contributions to HVAC education.wikispaces.com are licensed under Creative Commons Attribution Share Alike 3.0 license.
Close
So
enough.
share alike means not to do changes in it.
Close enough. Do you want to share then, Shandor? Can you do that?
Yes, I'd like to.
Okay, great. Thank you.
And I will make it first full screen. Just a second. Let me press on F11. Take off the toolbars. And here it is. Or maybe better not the full screen, but this is. I hope we can see it. So this is to understand what kind of motor types we can find there. So there are different ways how to start these refrigerator motors.
That's a straight inductive one.
Yeah, this is that one which has a starting device, a current relay.
Oh, let me get it on live stream. Let me say something before that came to mind, which was we seem to, the way I understand it is that it takes a minute or two or three to actually get that clicking to start in the refrigerators. The way I understand it, it takes a while of building up with the little starter circuit in order to build up enough energy in maybe the capacitor in order to start the capacitor start motor. I'm not clear on that, but it seems to take time in order for the click to kick in. So I'm thinking that's a clue to the type of thing.
Let me explain that. These compressors are working on a really high speed. And when they start working, they start, so they are speeding up. And when it reaches a certain speed, a certain RPM, then the helper start winding is not needed. So there are some versions of such a motors, like here, you can see on this top middle, they have a run winding, which is always connected, and it has a start winding, which is connected via a centrifugal switch. So when it spins at enough high speed, that is disconnected. It takes a bigger current because it uses two coils and the stronger magnetic fields at the start. And when it reaches a high speed, then it's disconnected. It's no more needed. And this is done in several ways. So one of the ways is with the centrifugal switch, usually the older models or the bigger ones, the huge ones. And for instance, there is another method with this capacitor in series with the auxiliary winding. It means the starting winding. The motor starts using both windings, so it's normal closed, this current relay. But as the motor is spinning and the main winding takes a bigger current, in that case, this becomes disconnected. So it says the motor starts using both windings as the motor in the capacitor start induction run system, which is its name, comes up to speed. The relay removes the start winding and the start capacitor from the circuit. So when it's running, the capacitor has no role. This happens about 1/3 of a second, and the motor then runs on the run winding alone with no capacitor. And why it takes more time in our case? Because probably the startup generator from battery, it's not a high power one. It doesn't have so much force. It doesn't give enough amps. It's a low power submersible pump motor. So that's why it starts slower.
I would go along with that, Soundless. I think the other thing is that for the average punter out there, they're just using a refrigerator or a refrigerator motor. This is all going on invisibly and independently beyond what is seen. And that circuit worry or the connectivity there shouldn't be of concern to people who are using fridges. It's only when you're going down to component level that you need to be concerned with the actual idiosyncrasies of that part of it.
Yeah, so practically when this is already running at a full speed, then the circuit is closed only through the main winding, and this one has no role afterwards. And let's see the other ways of connections. There is a resistance start capacitor run system, where is a PTC device. So it means a positive temperature control. When the current increases, it heats up and it creates a big resistance. So there is a run start capacitor, a capacitor which is used in series with the start coil. And when that takes a bigger current, this heats up and practically it shorts the capacitor. Sorry, not short, doesn't short it. No, sorry, I told something wrong. Sorry, need sometimes to sleep more to don't do such a mistake. So when it starts, let's annotate, when it starts, then this has a low resistance, so it gives current to this one. And after it started, once it started, this resistance becomes high, so practically it disconnects. And the start coil will be still connected, but via the capacitor, which will be in parallel with the run coil. So it will still take some current, but a small one. So here the capacitor remains in gain. But this is not the schematics which we had on the blueprint. This is a different type. Because here you see the PTC is not in series, but it's in parallel with it's in parallel with the capacitor. There it was not in parallel, it was just in ramification. So let's see other type, if there are any other. So when you start testing with different kind of compressors, you have to be aware that they are not all the same. There is another one which has a run capacitor and a start capacitor and also a starting relay. So it gives a high value capacitor which gives a high current for the start auxiliary coil. It gives a higher current, and after that it's disconnected, and then it's connected via a smaller capacity. So here both main and auxiliary coils are contributing to the running, and it's not completely disconnected like in the case which they use this current coil relay or the centrifugal switch. So there are two kinds of motors. Some use the start winding only for starting up and later is disconnected completely. And in other system, it remains still connected through a capacity, which is giving a reduced current. You have to understand the capacity in AC acts like impedance. It's something like giving a resistance. So not allowing too big current, it's a current limiting thing. And there are other methods also with just a permanent split capacitor. This is not very common, but you can find it also. You find it in many water pumps, for instance. The shaded pole, this is similar to what you have in a pickup motor. And there is also synchronous motor, fixed, when using fixed frequency. So this is synchronous, it's a different one. Universal commutator is different. This is a motor with the brushes. And this is another schematic similar to the first with a positive temperature coefficient relay. This describes how the PTC relay works, in fact. So these are not anymore about that. So there are about 3 main times which we can consider. So after it starts up, in many cases, the start winding or auxiliary winding has no role afterwards, but in other constructions, it still contributes to the spinning, but with a capacitor in series. I don't know if that capacitor thing makes any difference in our case, whether it's with or without capacitor. So practically, if we reduce the entire thing to the minimum, in that case, we would have just 2 coils here. This will be, one it's up, it's like having just two coils with a high inductance here. It will be interesting to make a test prototype and to start to try with both. So once it's proven that it works with the existing method with 2 compressor motors, then to try to replace the compressor motors just with simple inductance, with simple coils on some core.
Yeah, I wanted to mention at this point, we're getting kind of late into things. I wanted to ask if anybody actually has set up that they've replicated similar to what we see in the blueprint teaching for the hybrid system. Maybe we've been talking for several hours here without being able to see someone's new system that they've been patiently waiting to show. And I was just wanted to bring that up to see if anyone had actually created something that they do want to show, or have any leads as to that. If people can send their creations, their replications to blueprint at spaceshipinstitute.org, then that would be the blueprint site. Then we'll get those up right away to show what people have and try to get some more feedback on people actually trying the design. As Mr. Keshe said, you can discuss it and talk about it and everything else. He just wants us to build it, to try it. And someone else would say, well, what if I change this and do that? And he says, just do the design. Just try the design. Just stick to the design. So it's interesting, although we know the design is going to be changed in hours, days, at the very most weeks. It's interesting that we're trying to substitute different things. I'm just wondering if anybody's actually tried the actual design as laid out yet. I know that Guy's going to try it tomorrow, but...
Well, how did Lee, now Lee has a chance to see what's going on here. Does he have any good ideas?
Yeah. Just by the way, I erased now what doesn't play into the game after the system starts up. So you see it much simpler.
I was just wondering if you could substitute air conditioning systems for fridges. Would anyone see a difference?
Why not? It's the same principle. It's the same thing.
That's what I thought. Compressors, capacitors, same thing.
It's absolutely the same thing. So maybe you don't want to operate 2 fridges in your house, but you have an air conditioner.
Yeah, I can get hold of air conditioners easier than fridges right now, yeah.
It's possible, but see how it's reduced after it started up. So the circuit, the starter circuit is not anymore there. And this is the condition when it's all running.
Great,
and now you see what's interesting here. Actually, this part here, you see this portion, it's just a resonating circuit, including this capacitor. It's just a resonating circuit, and I think this would be a key. This is simply just such a circuit. It's a coil and it's a capacitor. That's all. And here you have a coil which operates like a choke. It's just a coil.
Well, I have to add one other thing here if I can, and I'll make this quick because I know you got to go, Rick. Okay, imagine that, right? The way you have that drawn right now, basically the Magrav coils and the capacitors, imagine that that's already a functioning plasma circuit, but you can't plug anything into it because it doesn't have the behavior of the what we call electron vibration. It's just a magnet plasma behavior that Tesla taught it. So that the capacitor, I mean the compressor, the refrigerators are a way to teach that behavior. It's a banana on top of that. Right there, you've got your plasma circuit. It's blank, and you give it a behavior. You teach it 50 hertz or 60 hertz or whatever, using something that's designed. There's something that's designed for that, and that's literally like transferring the energy. Now you don't need the banana. You got it in the fields. So all you're really doing is transferring to the coils. So it seems to me, now that you know that you need to have something to teach the behavior, you don't need 3 sets of Magrav coils. You just need, I mean, you might just need a couple of balls of Gans. I mean, you know, I mean, there's a certain configuration, the same 3 basic Gans. You probably could put a composite Gans and make a really small one. Once you teach it the behavior, you've got the fields. So now you can miniaturize it by using whatever you need to do to teach the behavior to a really tiny little one. Once you've got it, you've got it. That make sense?
What are you doing, Shandor?
I reduced it to what's in the game once it started to make it simpler, easier to overlook about the whole circuit.
Right.
But meanwhile, sorry, just before continuing, I see somebody has so many things to write, to tell that he's continuously posting on the chat. So, Rick, can you allow Alexis to have the microphone and to speak us a little bit, because I see he's full of things which you want to tell to us.
Okay, yeah. Alexa, do you want to, Alexis, do you want to speak then? Yeah, sorry, go ahead.
Yes, hello everybody. I'm from Romania. So we must not forget that between the Magrav coils, yes, we have some fields there. So on the 2D, what Mr. Shandor draw, we see something, but we miss that. And that vertical position and direction of the fields is very, very important, because in my opinion, is there where after you start the system and the pulse, the plasma pulse, which is not on the let's say this the battery don't have a ground, so that is why in the first time the plasma is developed there on the motor, you know, and after that is transferring the system where it stabilizes in the Magrav system, and for a time it will grow and envelop all the system. After that, you can unplug it, unplug the starter system, and you will have, let's say we said, infinite loop. But I don't think it is infinite loop. I think there is like cosmic law or logarithm or something like that, you know, that the plasma, it will maintain the system. And now we have 2 systems electrically, which the electrons flow through the cables to the copper, and the plasma, which is flow and maintain the electronic in the copper. And the compressors make the maintain the frequency, you know. And someone asked why we have the ground there. The ground, I think, is for the plasma to, like an anchor, to remain in the system in this how do I say,
it gives a ground point. So if you want to jump high, you have to push your feet to a solid base. So I think this maybe what you want to say, that the ground is just a fixed position from where you can.
Yes, in this frequency domain, like in our dimension, and the electricity part for the ground is what we know. So if you don't have the ground, the plasma will go bye-bye in the universe. So, or between...
I don't know if I agree with that. First of all, Mr. Keshe said on the system that was set up by Douglas that it didn't require any ground. And Douglas was merely putting the ground in because he was worried about the shock potential of not having any grounded appliances or any grounded tools or whatever.
Okay.
So I don't think...
Then the Magrav system, which is in a vertical position, yes, maintain that.
However, having said what I said, the idea of a ground may be like the common or the common wire, which is what that essentially attaches to in the output box there, is perhaps required, which is, you could call it ground. Like, you know, even if you're in an airplane flying in the air, they still have a ground circuit in the airplane. It has nothing to do with grounding it in the earth, though. Grounding it in the earth is a different thing. So we have to be careful of that, which is what Douglas did. He grounded the earth, but only to the third prong on the way I understand it was to the third prong, which was already connected as well to the common too.
Let me ask something from those of America. I saw that he has a special extension, which may be a de facto standard, which he had to clamp with the pliers, its switch, because he overloaded it over its specification and it would disconnect because it has a current relay. Doesn't it have also a sensor for ground? And if it's not grounded, it also disconnects, and that's why it was needed.
Not usually for the ground. No, that'll be a ground fault interrupt circuit, and it's rare that one of those will have the ground fault interrupt.
I suggest something. Maybe it's okay, maybe it's not. It's your decision. Let's take this ground away and let's put it in our electric car.
Right. Exactly. So. Okay, where are we at now?
We have seen Magrav units for cars, for instance, they have no ground at all, so maybe it's not really needed. And why you get an electric shock when you touch with your feet the ground and you touch the live wire? It's only because in the power station they ground one of the wires. They ground something, and that's why you have this connection. And the purpose is mainly not for making it safer for you, but to make it dangerous to touch the wire to steal electricity without paying for it. I think that's the reason.
That'll teach them.
Ground is not needed for distributing. And when you want to work in a safe environment, to have no electric shock, for instance, you work in humidity, or you're sweating because you are a baker and you have a portable lamp or electric tools here. They usually use such a separator transformer, which it has the ratio of the coils approximately 1:1 ratio. So it doesn't change anything, but it separates this part which is grounded somewhere. So it makes a groundless source of power. But that's not needed.
Okay, I'm still...
Sorry for interruption.
I'm still following you, Shander, up here on your drawing, where you now have, you've bypassed your compressor, and you've got a coil, 2 coils there. What would that be? Let's say, could I buy something that would fit there off the shelf?
Sorry, I have to recycle some pens. So I understand that this is a resonant circuit, which gives the pulse or the frequency which you need here.
Okay. Okay, now this right here.
And I'm wondering whether is it need for this portion from here to here? If you you would disconnect the second compressor after it runs, so we have to ask Douglas once to try to disconnect that. Will it still keep running? So maybe you can reduce it further. But it was said that it need for both because both are part of the circuit.
The infinity loop is at the core heart of the system, so it's like...
So here you have an infinity loop with a capacitor, so it's somewhere from electrical viewpoint, it's quite special.
Mm-hmm.
It's not a spark gap, it's like Tesla had, it's a capacitor.
Well, he always had capacitors and a spark gap. In fact, he had huge capacitors.
And also this circuit here.
His Tesla's capacitors were in...
So this is not participating to that resonance, but it's still interesting.
I've got a feeling it's necessary. It's kind of like an oscillator in electronics. It's like one part's rising and it's dropping. It reaches that point where they cross over. I mean, that's what frequency.
Well, that's right. And it's what's called, typically called from the old days, the LC circuit, which is an inductor capacitor circuit. In fact, there's 2 or 3 kind of inductor capacitor circuits. You could reduce the coils, the Magrav coils, down to just one resistor coil, or one coil rather, one inductor. And the plasma capacitors you could look at as a single capacitor in the circuit. So that means there's an inductor capacitor on the bottom part of the circuit. There's an inductor capacitor on the top part of the circuit. And that sort of gives you 2 resonating circuits right there. And if you have 2 resonating circuits, like in a radio circuit, then you can start to get like a heterodyne or super heterodyne. It's got to do with that beat frequency again, and the difference between those 2 circuits ends up with the pulse out of it and so on. So maybe there's a pulse within a pulse and they can resonate with each other.
Yeah, well, Mr. Keshe just circled that whole section and said this is going to be replaced, with solid state. And as soon as he said that, I just pictured a flip-flop circuit or it's like the railway crossing lights flashing, one side flashing.
Yeah, well, people have worked with these pulse circuits for many, many years, actually, and including right back to Tesla. He thought that his spark gap circuit with in his transmitters, he used huge capacitors, like huge tubs full of oil and plates and so on to be the capacitors, and like somewhere around a ton of copper wire around the bottom, and the same in his transmitter coil and so on. And he did have that spark gap as the pulse interrupter. That has an interesting way that works, because a spark has basically the voltage goes to infinity through when that spark happens, and if it goes to infinity, that means that the rest of the equation has to correspond accordingly with the amount of power coming out and so on. So it's a possibility of actually bringing in power from the environment. Pardon me? Sorry?
I was just saying there's an effect called back EMF, and it's when you turn off a light switch, you see a spark often, and it's electricity trying to maintain its flow, and you get this weird sort of backflow of electricity.
That's right. Same as in a car, you don't get the spark at the spark plug until you disrupt the circuit. It doesn't happen while the power is hooked up. It happens as soon as the power is shut off. That's when you get the spike output.
For those who are not familiar with electronics, you have to understand capacitor is charged with so-called static electricity. then the circuit being closed, it gets discharged through the coil, and through the coil, that energy which comes from the capacitor gets transformed into a magnetic energy within the core of the coil, inside the fields of the core, which when you interrupt the circuit here, the capacitor is depleted, so it has no more energy. It means the circuit is open. Then this one starts like a push-pull to feed back the capacitor. So what it got from the capacitor, it gives it back. So it is an electric energy, here is a magnetical energy, and there is a push-pull action in between. And normally, if you make such a circuit and you trigger it by connecting it to a circuit, you charge the capacitor when you put it there, then it will give an output in the form of a wave, but that will silence down after a while because of the lost energy, which is losing through radiation or through the resistance of the components. But if you have here the plasma, and plasma gives where it's need, so that keeps exactly in that same rhythm to give what it needs. So it keeps this, with plasma, it keeps it running according to the needs. And if you increase the load at the output, the plasma, it's increasing what it gives to it also.
The amplitude, yeah. You're maintaining the amplitude rather than it reducing, yeah.
Yes, so maybe with this simplified drawing, some of us got an inspiration of where to go to make a solid state device without moving parts. So my idea when I heard last year about some blueprints will be released, so this was before the ambassadors meeting and the release of the blueprints. Release of the blueprint started on the 26th October. So then I already went to the shop and to find some good casing for such a portable Magravs or one for home, one for car, and so on. And maybe this is the way to go, to not for huge boxes, but to something small like this. This is just a certified, it's a TÜV certified device where you can put your extension cord where you put the plug here inside, and this is not need actually for it. So one wire goes in, one wire goes out, and inside it was my intention to put the coils. So later we got this requirement for gauge 14 or 1.6 millimeter diameter wire and so on, and bigger coils. So I didn't use it, but maybe now it's time to work on making something smaller, which fits here. So they would fit the coils, the capacitors, and whatever other small parts. Just have to go to miniaturization. It will be no problem if you do not give 100 kilowatts at first, but even if it proves of concept, it works in a small size, and then we have something to test how much it can give out. And from there on, we can scale it up.
Yeah, that looks great, Sandor.
You can find such things, I think, everywhere in electric shops. It's a not a waterproof, but it's a drop-proof enclosure for extension cords outside. So you have two cords and you plug them together. Then you put the plugs here inside this.
Yeah, just make it a bit more weatherproof.
It's not to submerge in the water, but if it's outside in the rain, it's no problem with it.
What you have there too, Shandor, you've got the two ends there is where you put your double balls on the end, where you have the double spheres, where you have a magnetical sphere surrounded by, a gravitational sphere surrounded by a magnetical sphere. There's still that thing that we really haven't experimented with as well. The fields that go between two double cord balls or spheres.
All possible. Just this system has no double cores, just simple cores.
No, but there can be, as you start to look at these and you put together the different supposition, there can be double cores. Just the middle coiled, you do not put a ball in there. You put the two balls on the ends, and they're double.
Why not?
And there you've got your infinity loop that way.
Well, why not? And here also, you see, here you have the heaviest fields here in the middle. You have a copper here in the middle, copper oxide. That's heavy, it's a 96 or something like that. And 44 CO2 is here, and 15 is here. So it makes once a loop from here to here. So let's draw it in this other way. So it makes a loop here, it makes another loop here, and probably it makes another one here between these two. It makes a compact flows of the fields. That's from the plasma viewpoint.
I was just wondering if I can get in a question to John or the innovation team. Mr. Keshe talked about the difference between 110 volts and 220 volts as far as starting the circuit up. I wonder if he's got, John, you got any input or any experience in that?
No, sorry, I can't help you with that. Other than he did mention that the 220 or the 240 volt is a lot fussier to get started.
Yeah, that's what I was locking onto. Yeah, I just wonder what that means. Whether it's just going to, I guess I'll find out. I'll report back.
I think all the thing is here that you have that starter circuit with a battery charger, supposed to have the battery full for next time. You have a DC motor, and that spins an AC motor, which you use as a generator. And if you make it for 230 volts and not for 120, in that case, you have not to follow the specifications which are here, like a refrigerator compressor for 120 volts, AC 60 Hz, but you use for what you have in your own equipment. So if you need 220 volts, of course, you use compressors of the 230 volts, and also you make the startup circuit accordingly to heat for 230 volts. So you don't go for the specifications which are here for these electronic parts, but you find which is suitable for the purpose.
Yeah. There's no problem at all. Yeah. Look, all the information is here. I mean, this is such a gift. You know, no one gives you plans like this or gives you such detail. It's beautiful. And yeah, let's get building. Let's
get building. That's right. Lee Coates was the only one that showed anything today that was relatively complete. So let's see if we can come up with at least half a dozen for next week, and preferably more. I mean, there should be. I'm sure there are hundreds of units being built out there right now, possibly even thousands. It's just people coming forward and showing it. So get it into the blueprint site so we can show the public, and let me know, and try to come to the meeting next time, maybe on the Knowledge Seekers Workshop on Thursday. I know Mr. Keshe is really wanting people to do this and really wants to see some results. So we can talk about it up the yin yang and ask questions up the yin yang, but we need to just try it. Like he says, just try it. Just try it. Do the design. Follow the design. But what if we add this and that? No, follow the design. You know, it's like so hard for us to put these simple things together and just try it, and you know, maybe vary some things, but just try the initial design first, and then we can play with it. But yeah, it'll be fun, and we'll see if we can keep up with the changes that'll be occurring in the next while for sure. I see there's a question with Stephen L. France here. He says, please, the starting circuit is therefore essential if I start to test my circuit with a cable, a 220 volt wire basically, is that okay? Is the starting circuit therefore essential? And yes, it is essential. That's what Douglas has proven. Yeah, ask Douglas if he thinks it's so it's definitely essential, and we were trying to figure out earlier exactly why and how we might be able to replace some parts and so on. But again, I think we have to try it and see if we can get it to work as is. And if we can get it to work faster, easier, better, smaller, and cheaper as we go along, then open to lots of ideas, that's for sure. Let's see what works and keep the development going on this. I think we should wrap things up pretty soon here. It has been going for 4 hours. So, what are you writing there, Shandor? Are you giving the magic formula for the ultimate?
Oh, we lost the volume.
Oh, we don't have your. We don't have your.
Sorry, I got a phone call meanwhile, and this I put the starter circuit, the place of the starter circuit into this one.
Okay.
We have a starter circuit here, which you use. You insert here the power what you need, and then you switch it off later after the start.
Right. Thank you. Good. Fun exercise. Okay. Is there anything I missed here? There's let me see. Just want to check, make sure we got. There's Bob is asking about the. I haven't had a good look at that yet, Bob. I've kind of got into all this other stuff. There's so many things going on that's not the direct hybrid reactor stuff, or hybrid generator rather. I'm trying to focus on the hybrid generator information right now in all of our workshops and that sort of thing, rather than some of the Gans questions and so on that tend to come up. If we can try to get focused on the generator as Mr. Keshe would like us to, I think that would be great if we can get some results on that. But Guy had some things he wanted to show here, but it wasn't directly generator related really, but they're cool double core reactor things and so on. But we don't really have time for that now because of getting into so much of the other, which I'm so glad we got into. I'm glad we got into this. It was an excellent discussion from all different angles. So, any other things to add before we phase out here, before I phase out myself? Okay, then I will stop the live stream, and I will thank everybody so much for attending, and thank you too for the people in live stream. I wasn't paying as much attention there as I can, but I haven't seen too many questions. It's mostly comments to each other. Appreciate the support there. Okay, we'll end the live stream and see you all next week at the Keshe Plasma Reactor Group.